All right, everybody. I know we're still going to have a few people trickling in, especially as we go, but we have a busy schedule today, and I am thrilled to welcome you all to the inaugural DeSci SF event, DeSci 2022. So I don't know about you, but I'm stoked. Yeah, a quick round of applause for you all. This is as ground floor as it gets. So DeSci is the start of a new movement within one of the newest spaces in technology, and I couldn't be more excited. And I have a nice little thing over here where if you guys want to get a poke for having been here today at this event, you can go and scan that QR code right now. Now, this is a tricky practice. You can trust me, but in general, it is not great to be clicking QR codes from random people that you get. But we have made this one available, especially for you today, so that you can go and be part of this epic moment in our history here. I also want to say a quick thank you to our sponsors today. Let's do another quick round of applause here because, I was telling Danette before this, when we were organizing our DeSci Day at EthSF, at EthCC over in Paris, we did almost do it in a park during a 110-degree heat wave. Not to knock DeSci events in the park, DBDAO, Dolores Park tomorrow. I highly recommend you go. And I also like to give a special thanks to Letitia Shaban on our team at Weavechain, who many of you have been communicating with and who did the lion's share of the work to make this event happen. But the companies on screen here today are making sure that we are air conditioned, fed, and caffeinated to go and change the world. And I hope you leave today feeling like anything is possible. So our theme is impossible is not a scientific term, and you're going to get to hear from and talk to the people who are changing the fundamental architecture of how scientific change happens. We have a busy day lined up, so I'll be kicking it off with some introductory remarks and my take on DeSci. And then the team from Protocol Labs will jump in with a keynote on their compute over data solution. After which we'll then do a speed networking section that I'm really excited about. And then Jordan from SpaceDAO will wrap up the morning before lunch. And this afternoon, we have an incredible series of talks and networking, punctuated by Allison Duettmann's keynote on tech trees and gaming the future. Now, Weavechain will be buying the first round at our happy hour here at Piano Fight, but then we will be decentralizing the bill and once our tab runs out. And then similarly, I'd love to do a buy your own food and drinks meetup at executive order after the event. Note the path here from Piano Fight to executive order. I really recommend staying on Market Street as much as possible. Depending on your sort of comfort level in a city like San Francisco, the Tenderloin can be a little tricky. Now, one last bit on logistics, our speed networking sessions today. We're going to do it middle school style. So each of you have a color on your badge. I'm red, for example. And, we have yellow, green, and blue as well. And for each speed networking session, find somebody with the right color or a small group of those people to chat with. So we'll start off with each color chatting with each other. Red and yellow here in the theater and green and blue up at the bar. Then we'll mix it up and red should chat with yellows and greens can chat with blues. And then in the afternoon, we'll have reds chat with greens, blues with yellows. And for our final bit, we'll make blues and greens switch rooms. Don't worry, I'll shout out instructions in real time and nobody here is being graded for their performance. Now, I love the logistics. I want to kick off the day by giving a brief overview of DeSci, starting with what really is this whole vision for decentralized science. Now, I have imposter syndrome to even feel qualified to give this talk, but DeSci Labs, however, described a really interesting vision of the Web3 of science back in April that I loved. They described this transition from the Web 2 of science. And it started with a problem that I commonly hear, which is that science is broken today because of the existing publishing infrastructure. Now, back at our DeSci Day at EthCC, Tomiwa Ademidun talked about the problems of this triple pay system, where scientists are basically doing free labor that's funded by governments, and then publishers like Elsevier are taking home 40% of the actual value being generated there. So the first step that I've seen decentralized science tackling is to fix this funding model. Organizations are rallying to promote healthier funding models for scientific research, for scientific publication, for IP ownership, for the business of science. And I think fixing value share is one of the best attributes of well-designed crypto tokens. Now, I'll note that designing a crypto token, well, isn't the easiest thing in the world, But at least there's a shot here. A shot to go and design systems that spread the value, excuse me for a moment, spread the value back in favor of users, creators, and builders. And I'll note here in this model as well, you should also be respecting capital. I'm a capitalist, which is kind of a dirty thing to say in a DeSci crowd, but economics has funded the modern era. And without investors, things slow down tremendously. It's a lot harder to go and make change happen. Now, once funding has been resolved, let's go and fix governance, right? And reputation. I talked to academics and they feel trapped today, forced to either conform to the system or face exile. And DAOs have incredible potential to improve decision-making with radical democratization methodologies. New forms of governance, like quadratic voting, are being rapidly experimented with. And look, we're early days. It's not all good so far. I'm in a lot of conversations where many DAOs are being panned as ineffective and failing. And yet at the same time, I see many more DAOs popping up. Oops. I got a fickly scroll wheel over here. I see lots of other DAOs that are being panned as ineffective as failing, but at the same time, I see many more DAOs popping up to try something a little different, to fix problems that they saw with the last model and do better next time. Now, to govern properly in a digital world, we need a way to know the identities of individuals and to establish reputation in a codified way, not with deal making and special appointments. And I have very good news for you all. Web3 is based on security technology that can make this possible. Now, I won't get too technical here, but I will use a quick analogy to explain this. Now, please raise your hands if you are familiar with HTTPS. Yeah, this is a good crowd right here. All of you use HTTPS every day. It's that little lock icon in the top of your browser. This is 25-year-old technology that is currently on 95% of websites today. And it took 25 years to actually materialize. And it solved a very simple problem. I want to securely communicate with a website. To do this properly, it had to prevent somebody faking that they were docs.google.com when they weren't, and to prevent people from injecting fake information into our communications once I am sure that it's docs.google.com. Now, Web3 technology lets us have trusted transactions amongst many parties instead of just two. We can have a shared ledger of reputation data, for example, where we are sure that anybody who wrote to our ledger was permissioned to do so and is tracked in a way that can't be changed historically. Now, let's combine this with technology that's referred to as verifiable credentials. So, you should think of verifiable credentials similar to your driver's license. There was an issuer, the DMV. You hold it in your wallet, and you present it to a bar like Piano Fight, and they validate that it's authentic, and then you get to drink. The same thing is happening with that SSL certificate in your browser, right? This was issued by a certificate authority over here, and it's hosted by the website, and then you are the one that's actually validating that it's authentic. And I propose that the exact same pattern is going to happen with pretty much every credential you can imagine in the future. Your licenses having been an alumni from a specific college, or being part of a hospital network, or part of a technology group. And this is a great thing. This is technological infrastructure that's enabling companies like Decentralized.science to go and bring back control to the academic community and to do better peer reviews. And I know teams like DeSci Labs are working hard on this problem as well. Me, I'm a data nerd. So my focus at Weavechain is on how we can have a better transfer of bits between parties, the flow of data itself. Now, for DeSci Labs, they recently launched a product called DeSci Nodes that's beautiful. The concept is that today, people just publish these PDFs where you can't validate any of the information that's inside of them. Instead, they built a plugin that's attached to these PDFs that has verifiable metadata that shows, where's the source data that was used for this study? How was the paper reviewed? And how was that review verified? Is there actually reproducibility built into this research? And all this is done on IPFS, which is an incredible decentralized database for open science. I think that Web3 data is revolutionary. Again, it's rooted in security technology, and it creates a world where users can own their own data. They'll have these cryptographic guarantees that their data hasn't been tampered with, and that they know who's using it and how. And I think the hope for a lot of users is that they'll actually be able to derive more value from their data by being compensated with tokens directly for that data, as opposed to just getting a promise that a service is going to run a little bit more effectively. And, ideally be able to use privacy-preserving technology so that they're not being exposed to the world, and use it in these really interesting dApps that are coming along. But we saw a problem at Weavechain, which was that, like public Web3, we think is best for public goods, right? Technology that we really respect, like IPFS, is tricky because everybody has a copy of this data, and you don't have the ability to satisfy, GDPR's erasure obligations, right? For data to be GDPR compliant, you have to have the right to be forgotten. And on a service like Arweave, for example, the permaweb, you can't delete data by default. This data is also not HIPAA compliant. For data to be HIPAA compliant, you can't just have technical safeguards like encryption. You also need to have physical safeguards, things like firewalls, and making sure that only certain machines can actually access that data. And I believe that these regulations exist to protect us, the users. I've signed on to the My Data Consortium, which is an organization that's pioneering thought leadership in this complex space to figure out the right way to treat data to be in the benefit of users. So our solution at Weavechain is to add Web3 benefits on top of a normal compliant infrastructure that many of us are used to today. So an application stack running in an AWS with some databases and a compute engine. Our nodes are deployed on premise, right into customer environments, connecting to data either via an API or by listening to any database from MySQL to Mongo. And then, our trick is that we're only going to put a one-way hash of the data on chain to give it those really nice Web3 security benefits, but keep the data off chain to go and maintain GDPR and HIPAA compliance and give maximum flexibility to data owners. Then we act as the gateway for all data transactions by letting people run API calls to our nodes so that you can do things like compensate people with tokens for data. Now, I think if we've solved all of those challenges listed previously, that the last exciting bit of DeSci is really going and trying to incentivize more grassroots activity. And, Tomiwa said it great this summer. DeSci makes it easy for anyone to contribute to science. And I'm excited to say that it's not just a blind anybody. DEI is top of mind for almost every one of the practitioners of DeSci that I talked to. Paige from the Women of DeSci told me this summer that diversity, equity, and inclusion is real, important, and necessary, and we agree. Over half of our long-form talks today are from female speakers. Genuinely, just because so many of them were putting forward such awesome proposals. And, I hope that I'm representing my Egyptian and Mexican heritage today here as well. But it's really exciting to see that, decentralized researchers are achieving incredible things right now. This summer, a decentralized science project contributed to a COVID vaccine that doesn't require deep freezing. This is really incredible stuff. But, even before scientists and thought leaders, I see companies trying to incentivize the average person to do more for science. Dr. Kyle Bergquist is a pain relief specialist from Northwest, and he founded a company called Reputable Health that's trying to build a better model for science using Web3 technology. So he's connected with researchers that are hungry for as much patient data as they can get their hands on, whether it's from your wearable heart rate and sleep data or your glucose monitors. And his concept is to go and see if he can incentivize users to share their data by giving them tokens for that data and guaranteeing them that their privacy will be preserved. So he's working to build out this Web3 wellness data economy that I think is really fascinating. And there's a lot of other companies that are doing similar things out there. We were chatting outside about Voluntas earlier and Data Lake. And, if this model comes to fruition, you're going to have so much more data available for science than you ever have before. Now, I wanted to show you a little bit about this privacy-preserving technology. Let's take a quick poll again. How many of you have heard of confidential computing? Just quick raise of hands. Awesome. Not zero, but not quite as many as our HTTPS analogy. So the idea with confidential computing it's similar to sort of what you hear with zero knowledge proof sometimes. It's this idea, how can I go and run research against a data set that I can't see? So let's say that we have a hospital that has a ton of patient data on its servers that it just can't share in a raw format with researchers. In a compute to data scenario, we're going to say, okay, researchers, I'm going to go and give you a schema of that data. You go and design your analytical process, and then we'll run your process on our servers against the data and just give you the results, but never show you the raw data itself. We love this model. There are a variety of different forms of confidential computing. We support compute to data Weavechain, as well as federated learning, multi-party computing, homomorphic encryption. And one of the really cool things here is that you add Web3 security to this process, in our situation, by going and hashing the data that's being used to the blockchain, the compute engine that's being run, and the results themselves, and having each one of the nodes involved in the system actually sign that they performed this calculation. And we're looking at a one-to-one scenario over here, but we can do this against multiple sources as well. If you've gone and designed this research process, why not go and suck up data from every single source that you can get access to? Let multiple hospitals contribute their data without necessarily sharing it with each other. Let data exist on end user devices without ever moving to a centralized location, but still be accessible for research. So these are pretty abstract concepts. So I wanted to actually show you a quick demo of how we do this using Weavechain technology. So let's say that we have an interesting producer of data, Acme Medical. We're going to go and set up a Weave, which is our branded term for data that's tied to a blockchain. They'll go and attach their existing oncology patient database to it, share it with a consumer, Oncotech, who will go and connect to that Weave, pay some USDC to replicate raw data to its servers, pay some USDC to run confidential computing, and then analyze all the hashes, signatures, and some ZK proofs that were generated to go and give this data really nice Web3 properties. So let's see how good I am at doing a one-handed demo while holding a microphone. I'm going to start by launching a Weavechain environment over here, and I'll create a new account, which in Web3 terms is really just a public-private key pair. Let's say this locally. And this will be for Acme Medical. Then we'll create a Weave. And for our product, the first step is actually launching your node, which we'll be doing in Docker. The second step is saying, I want to go and put this oncology data on a specific blockchain. And we support a variety of different blockchains to store your hashes. We're doing our own layer 1 that's optimized for big data. And then now I have my Weavechain node running. So we finished our setup. Now let's go and attach a database. Here, we're letting users operate with whatever database format they're comfortable with. We're just entering the connection string over here. And then we see that our database has a directory of hospitals and some patient data. Now, this is a critical step. We don't want anybody to be able to access this patient data in its raw format, only with confidential computing. Then we'll go and establish some fees for this data and say, all right, researchers, you can go and run computation for 100 USDC per day, or you can go and access our directory of hospitals for 10 USDC per 100 records. Now, the last step over here is we need to say who can actually run these processes. We're doing this with fully role-based access control. We think this is the only way you can really do things for really sensitive data sets. So I'm going to go and log in with my user from Oncotech. And he'll copy his public key and say Acme is going to let Oncotech read data and run confidential computing. We'll copy the node address from Acme, and then Oncotech will say, I'm going to go and join that Weave. Now, let's have Oncotech pay some tokens to go and replicate raw data. So here we have the Oncotech environment, and let's say to sync this data into Oncotech's local database, it's the same situation. He's entering his database credentials, but now he's got to go and pay some tokens to access the data. And once he does that, he can see this directory of hospitals, but he cannot see any of our patient data. All he can see are the field names. And this is the part that I think is really exciting, is let's go and make it so that we can run some research against that data without ever having seen it. So our Jupyter environment is just running some code over here where I'll connect to the Weavechain node. I can read from that directory of hospitals the same way I could from our UI. But I can't read the patient data, right? I'm not authorized to do so. What I can do, however, is run a linear regression or understand the correlation between smoking and severity of cancer just by knowing these field names. Right? I'm running this research the exact same way I would locally, but I've never seen the patient data. And this can get as complex as you want. I could go and train a machine learning model on this data set using that compute to data technology I mentioned earlier. So here I have all my Docker containers. And when I run this bit, it's actually going to go and spin up a Docker container in the background over here to train this machine learning model. Now, my computer's running a little slow today, so I'll do a quick bit of movie magic and just show you what this model looks like once it's generated. And the great thing over here is that, I can go and use this model on the data to understand, the importance of things like alcohol use on severity of cancer without ever having seen the data itself. And like I mentioned earlier, we're going and creating hashes of every bit that's happening over here. The inputs, the computation engine, the output, and signing it by the node that actually performed this calculation. Now, another slow bit over here, we enable zero knowledge proofs on that data as well, so that I could go and debug the patient data by ensuring that none of my patients has an age that equals 0 using zero knowledge proofs. And the end result for Acme Medical, again, is just that they have securely enabled access to their data and earned some USDC from a consumer that ran some research on their product. Now, I appreciate you all bearing with me as I ran a pretty technical demo over here, but this stuff is important. I think we all need to be worried about privacy immediately, because really technology is only moving in one direction. I was watching QuarterCon a few weeks back, and Vodafone was talking about how they're working to go and create not just the Internet of Things, but the economy of things. They see a world where every device is connected to every other device and sharing data in real time in a transacted way. And, if this is done wrong, it's dystopian. If it's done right, it's in fact more secure and creates more privacy than you have today when you're using technology like confidential computing that I mentioned earlier. Again, though, this can be some creepy stuff if not done right. This is why we're really excited when we're doing our work with companies like Mama Root that are working to use IoT beacons that understand human movement patterns in the real world. They're running a pilot in Japan where you literally earn tokens for exploring a store or a shopping mall. Without that store or shopping mall being able to understand where you personally are going during the day. They're going to make it so you earn NFTs for exploring different parts, like visiting locations in a Zelda game. I love these ideas. They're really exciting, but they need to be done thoughtfully and done correctly. And it's not just, location data or medical data. We're working with another company called ClimateCheck that's going and trying to incentivize the collection of data that will help in tackling climate change. They're a Nigerian company that's selling users a little box that you can put in your house that will be collecting air quality data that they then sell back to refineries in the area that are trying to conform with ESG standards. The idea is simple here. If you're an end user, you buy one of these boxes, you plug it in, it pays itself off in 6 months, and then it's just a recurring stream of revenue for you in the future. And you're going and helping the world while you do it. This is a complex map. I'm not going to go here and say that decentralized science is simple, but there are different people that are working on every part of this problem. This is what the DeSci landscape looked like in February this year. There were 47 organizations tackling different pieces of that problem. And here, less than a year later, we've increased that number by almost 3 times. Raise your hand if you're here today and you're part of this landscape. Any other of the, there we go. I know lots of people are part of this conversation and excited to go and be a part of this tribe that has this awesome vision. Because we all want these things, right? We want to go and fix the funding model for science. We want to fix how governance happens and fix reputation identity and have data moving, more securely between parties and incentivizing more people to participate in science. And I'll close today with one last note that, from where I'm sitting, I see academia and industry wanting to help with this evolution. It's sort of easy to say we're going to go in and, recreate everything and do it better this time. But I think there's a really interesting opportunity here to partner with the institutions that already care about this and have set up an incredible infrastructure to do so. Just 3 weeks ago, I was at the North America Blockchain Expo, chatting with the blockchain teams at Pfizer and Johnson & Johnson, who are super interested in decentralized science. They're part of consortia like Melody and PharmaLedger, who are doing really challenging things from a legal perspective, like nailing electronic consent to go and participate in a decentralized clinical trial. And academic institutions like Stanford and Berkeley are bringing brilliant minds to bear to support our efforts. And I think we're all stronger when we work together. And if we do, nothing's impossible. That's it for me. So thank you all again for coming today. And I hope you enjoy the great conference that we have lined up. I'll pause for one more moment for people that have trickled in during the chat. If you want to go and get your POAP for today, you can go and scan that QR code on screen. We'll try to intersperse it throughout the talks today. And the good news is we're actually running 3 minutes ahead of schedule. It's I was chatting with Duncan earlier, and he said that this venue is mostly for comedians who are never on time. So we're doing a great justice to Piano Fight. So I'm going to take a moment to go and see if we can go and bring on our next speaker of the day, who is Dr. Iryna Tsimashenka from Protocol Labs, who is going to be chatting about compute over data for data hosted that's on IPFS and Filecoin. So forgive me.
Thank you for letting me and Baechle team to present today. My name is Iryna, and I work for Protocol Labs for the project name Baechle. It was on the previous slides just a moment ago, and which is a very funny word, and I haven't been heard about it before I joined the project. So to give a little context, the Protocol Labs, the project is run by Protocol Labs, and our experience is around decentralized peer-to-peer storage technologies. So it's around like Filecoin, IPFS, and significant portion of our team are researchers in crypto, engineers with a scientific background. And a lot of work in the past was done of taking the large data sets and putting them on IPFS or Filecoin at a little no cost. And today I would like to talk about our new project, Baechle, and with a funny title, Bringing Mohammed to the Mountain, Compute over Data, hosted on IPFS or Filecoin. So this is a new way to run any computation on decentralized data. So instead of moving mountains of data to your program, to your computation, instead of it, we move computation to the mountain of data. And just a bit of like as an introduction, there is no need to there is no limit to any languages or data. Everything is supported as long as you can put it in Docker container, or you can or WASM, you can run it and use it. So just a quick question. Could you please raise your hands? How many of you have heard of IPFS? And can anyone tell me how many hands have been raised? Sorry, I didn't hear you well.
Half the audience, Iryna.
Half of the audience. Okay, I will quickly go I will quickly talk about what is IPFS and the main advantage of it. So think of IPFS as a distributed system for storing and accessing any files. So so it's a network that connects. It's a public network that connects any storage. So, for example, I have a spare disk on at home running. I can just go and plug it into the IPFS network and get some kind of profit out of kind of lending my disk for the storage. So someone will use it. And the main advantage of IPFS, which stands for Interplanetary File System. So it's the main advantage is it's decentralized, so it makes it possible to download the file from many locations that are managed by one organization, right? So, and also it's content-based opposed to location-based. So usually what we do on our computers, we identify by where it's located. So we give address to the file, on which computer it is, or which server it is, which folder it is. And instead of this location-based, IPFS address a file by what's in it, right, by the content. So the content identifier above is a cryptographic hash of the content that at that address, and this hash is unique to this content. And so although it looks like way shorter than original content, it's still like unique. And also this allows you you as a user to verify that you got the content that you asked for. So if there is a bad actor in the network, they can't just give you any content that doesn't match the hash. And even if you don't know the content, if you never saw the hash, there are tools for you to check that hash and content that matches each other. And the third advantage, it's of IPFS network, it works well for participation and possession. So where many people or organizations possess other people's files and participate in making them available. So it means that if I give you address to the server like AWS with where my files live for some research or to process it or for you to verify it, if in a certain amount of time I stop using AWS, you cannot reach out to those files, while with IPFS it's always available. So this is quite a famous popular decentralized network. It's been used by a large number of companies. So at this point, we have around 13 exabytes of data, like 13,000 or so petabytes, if this is correct. And so we got feedback from our developers, from engineers and researchers, that it's great, the system is great, but it's hard to play with this because the data is so large. So what we decided to do is to build another layer of network on top of this network, which we call Baechle, which is a Portuguese name for code. I will talk about it later, which code stands as acronym for compute over data. And so compute over this network is kind of system for distributed computations over data, and it's a public network. So anyone in the world able to join this network and offer compute resources, the servers, and also anyone in the world can join this network to connect to this network and ask servers, those kind of participants, to run some work for them. And Baechle, so anyone can join it, and anyone can request the work that it should be done. And Baechle finds the most efficient way for running this computation on data that lives on IPFS, on this interplanetary file system, this decentralized system, where data is public. And so the way that you should think about it is you just like write algorithms to process like large data, and you don't want to deal with moving large pieces of data to some servers to run it, and you have to pay for network, for ingress, for downloading it, which is also very slow. And you want to delegate all this. You want to delegate it to the network that will do it in the most efficient way and coordinate this large data. And it's also self-sustaining marketplace. And so it means that it will find the most efficient way of running it. So why Baechle, right? So very large data has a gravity, right? So it's, as I mentioned before, it's very difficult to move this data to your computers or to the servers for computation. A large part of this of this project strategy is how to optimize computation over large large data sets, over big data. This copying is expensive. Network is expensive, then storage on the storage is expensive, so you have to pay for disks as well, and it's long as well. While the job itself is small, right? Although we might write algorithms and it will take for us months to write and might be like lots of lines of code, but in comparison with the data that we run it over, it's usually like our source files or scripts is relatively small, it's incomparably small. And what Baechle is offering is a really efficient way of running these jobs over data and allowing scientists and researchers to delegate this job to someone else. So instead of sending data where your source code lives, like these large petabytes of data, source code it's possible to send source code to where the data lives, and this is primarily question and idea that behind Baechle. And so, as I mentioned before, it's a Portuguese word for code, and code stands for compute over data. And so, again, let's kind of think about like what problem can it solve. It's meant for currently it's already a live beta project, which was announced yesterday. And it's a network that allows to delegate to these jobs, these algorithms, to run over data that's stored in IPFS, where this data is public, and it works really well with IPFS and Filecoin. So it's native extraction of data and writing into IPFS. And we aim to compute any workload and any language. So also abstract way the complexity of a smart contract. So you just do a very short command on your command line to request Bacalhau to run it. And what kind of like jobs can it run? So anything that you can Dockerize, which means anything, any languages, and the WASM as well. So if you're just like WASM is a WebAssembly, is a portable binary code format, right? So it's a the main goal of WebAssembly is to enable high performance applications on the web pages, but because there is no specific web assumptions made or features that that WebAssembly provides, it means that it's possible to run it on any environment. So that's why quite a lot of languages already have WASM support. So you can basically you can basically build this like WASM binary code format out of your software, out of your program, your algorithm, and send it to the Bacalhau. The inputs is IPFS, or you can also, if you don't use IPFS, you can just specify URL, and Bacalhau will download it for you somewhere. So you don't need to you don't need to worry about storage or efficient computation, and the result of your computation are stored in the files in IPFS or Filecoin, right? So you have your software that's possible to put on a Docker container, and you set the input as a URL, and you just like you run Bacalhau, run this container and this input data with this URL, and it will download the files for you. It will run the computations, and in the most efficient way, the network will find the most efficient way. It will delegate the job to the servers that live near your data, download the result, run the computation, and then output will be provided in IPFS file. And the other advantage is that even if you don't have, like, for example, GPU or any other like latest hardware, Bacalhau has it, and it will run it on there. So you can also specify what hardware you would like to use. So I spoke like to quite a lot of software developers about this project, and they were always like try to compare with solutions that already have, for example, distributed AWS Lambda. So it's so let's kind of compare these two solutions. So it's AWS Lambda is good if you store your data on centralized, like AWS, for example, S3 technology, and use it from there. But again, it's centralized, right? And we are in a kind of decentralized world. So that's also the question. Another benefit is that Bacalhau is so the number that I heard is like 4,000 times cheaper than AWS S3. So it makes sense to compare it again, at least against the costs. And the thing that Lambda is good at, if you don't store your data on AWS, is to kind of where you send a function with the input already in the function. So it's like very small data. And for example, where there is like, for example, product as input and customer as input, and the function will return if the customer is likely to buy this product, for example. So it's not large data sets if you don't store it on AWS. So another question I've been asked, are we trying to build something that Ethereum founders wanted to build in the beginning as a world computer? And we are definitely not trying to build world computer. This is orchestration tool. kind of self-sustaining marketplace, and it's coordinate this like large data for you, and it's placed with this like we are trying to build it for the data sciences and academics that are running quite a lot of heavy computation, data heavy computation. So we would love to hear your feedback. And another kind of comparison with the Ethereum is that Ethereum is a kind of extremely expensive and extremely correct world computer, right? So just to remind you that with Ethereum, when you submit your smart contract, it doesn't run on you just submit it to the network, and when the blockchain accepts your smart contract and list of instructions, it's every node on the network runs the same smart contract, the same computation. So like thousands of nodes. With Baechle, you can set up in settings how many nodes you would like to run, how many for verification purposes. So usually it's 3, maximum 10, right? So it's not as expensive. I mean, it just Ethereum and Baechle is completely different beasts that are built for different use cases. And so Baechle is more like a orchestration tool, and Ethereum, especially now, is quite popular among like DeFi, where you need to run like transactions, verify transactions like financial transactions. So another tool is a Spark like platform, and Spark main disadvantage for kind of data sciences and researchers is that it has a specific language that you have to rewrite your software. So, and then it will kind of run on. Then it will run. Spark will identify this kind of servers that needs to be run. With Baechle, it doesn't come with any programming language library. It allows you to submit any job. I mean, any algorithm, any source code or script. It runs everything. And there is like noise decay is needed, so it's quite kind of user experience is 100% more friendly. And now I would like to kind of I would like to share some of the QR codes with documentation. Technical questions are on Slack. So if you would like to try this platform, please go to documentation, and if you have any questions, we are there like 24/7, because team is all around the globe. We'll answer your questions, and we have a very helpful and supportive team of engineers. Also, Baechle Substack is our newsletter. So we currently have quite an interesting and exciting roadmap to support many additional features that we are planning to do in the future, like pipeline support, etc. So please feel free to explore if you're interested. If you run large data sets, if you run computations over large data sets, I would definitely suggest you to explore this platform. Please let me know if you have any questions.
Yeah, Iryna, that was fantastic. We can open it up to the floor right now. Does anybody have any questions for Iryna from Protocol Labs on Baechle? Sure. Just a moment. Here you go.
Hi. What great talk. Thanks so much. What do you anticipate some of the first use cases be, or which use cases have you seen sort of so far?
So the project started like 6 months ago, and we already have use cases. We have use cases within like weather company. So so just as I should mention, I started this job like 2 weeks ago, so I'm kind of at learning stage at the moment. So what we do, we have a project where we kind of store satellite data and analyze this data for the weather forecast. So this is happening. Also, there is a partnership with a Caltech physics school as well, where we're going to store the data and run computations over that data as well. So there are many kind of research-oriented topics already, also bioinformatics, like genome data sets, and as I mentioned, like geophysics. Yeah, quite a lot of wide use cases, and we try to encourage scientists and researchers to try use their use cases on it as well.
That was great. Thanks so much. Please.
So how do you handle data security?
So the data is public, and so the data is public, and if someone is trying to get your data, like steal your data, or what exactly you mean? Because it's a public data that is content.
Let's suppose you wanted to overlay this network on top of a series of hospitals that go on and have patient data inside of them. In the United States, those are protected by something called HIPAA.
Okay.
That's an example of a desire for, yeah. The other thing that can happen is if you have an arbitrary computation going there, it could extract the data, put it into another silo, and then sell it, which would not be very nice for the people that own the data.
So for these use cases, we have encryption that is running on top of it, and so the data, some of this data is encrypted, but usually it's like for public, right? So I have to come back to you on this. If you store some like private data, I would suggest that currently we are not allowed, like it's a public data that anyone has access to. If it's we also provide encryption and also trusted execution environments. So kind of soft servers with that contain the trusted execution environment, like Intel SDX and AMD. They are working on this part of security, kind of solving security projects, and kind of enabling these kind of like use cases for finance and for healthcare. Yeah, this is very much work in progress at the moment. Currently, it's for public data, but it's a great question.
Yeah, just to add on to that briefly, what I've seen IPFS really good for is, open science, these sort of public goods that are out there that don't require that sort of strict regulation. And I think, even in the early days of the DeSci movement, people were like, is DeSci the same thing as open science? And in my opinion, open science is sort of a subset of decentralized science, where, it is for these public goods that don't have the same sort of restrictions associated with them. It's not going to be for all science, but, the more public goods we have out there, I think the better. Any other questions from the audience for Iryna, Protocol Labs, Compute Over Data? Please.
This might be out of scope, but how do you deal if like you need to do like message passing between different computations? So say there's like some dependency and it's not
Good question.
Parallelizable.
So just for kind of we are currently running Code Summit, and there was a presentation on the DAG, so pipelines. This is our work that is happening in progress. Great question, and yeah, we are like quite a lot of new features have been like adding work in progress at the moment. So yeah, it's not available now, but it will be in the very near future.
Got it. How do you imagine you would specify sort of like dependent computations?
So what they showed, it's like a Python script where you just like identify that, okay, output of this kind of function is the input for another one, and then it was like very small, very kind of one line of like pipelines. But in the future, I expect that will I think that use case was also for presentation, that you don't want to show kind of like very large script. So I will also be interested if it's possible to have like more sophisticated DAGs. But I think it's possible. They were just like showing as example like a very simple one.
Cool. Thank you.
Great questions. Thank you.
That was fantastic. Any other questions for Iryna? All right.
Thank you. I'm new to this compute over data concept. Maybe a dumb question. How does the system scale with the number of users? Let's say you have many users trying to run computation over the same piece of data. How would that scale?
So it's a great question. So with IPFS, you don't store data on the same location. You store like you have copies of it, and then if there is so we currently tested only like 4,000 nodes. In the future, we will run it more. We will have kind of more nodes than 1,000. And if there are more than kind of many computers want to have run data, many requests that want to run data on the same data set, then the nearest computer, so it's like a queue, right? The nearest computer will get its first, then some kind of server that's a bit like further away will get it. Second, will start processing second job, and then what's happened is that this kind of like Baechle network, it will request the data from IPFS network, and then it's the same queue, right? So whoever got requested first, and then obviously it will be a bit slower if you add like thousands of kind of computations of the same or thousands of requests, but it's more kind of also like DDoS attack. We have to kind of make sure that this is not happening. So I think the main kind of resolution point here, that the data stored in several locations. So several locations will kind of distribute the work. So there won't be a bottleneck there.
Thank you.
Feel free.
My understanding on distributed data was that it was similar model to torrenting. I don't know if anybody remembers BitTorrent. Correct me if I'm wrong. I'm right. I did it. I remember something I saw on Twitter.
My torrent download speeds get to like 50 megabytes a second. It's pretty good. Any other questions for Iryna? This is a great conversation. I think this is what we're looking for today. Getting people
it's very similar to a torrent. Yeah.
Well, Iryna, we have a few more minutes left in your talk. Maybe you could go and tell us a little bit about yourself. What you've been doing throughout your career, your history with Web3, and what really attracted you to Protocol Labs. You said you're 2 weeks into the job, right?
Yeah.
Congratulations.
Thank you. Yeah, it's been fantastic. So I was previously I was working in another Web3 layer 1 protocol, which is Mina, which is the lightest blockchain. So they use zero knowledge snarks technology to kind of recursively recursively kind of generates a small blockchain as a proof of all transactions and blocks that happen on it. And it's a great project. It has it's like cryptography heavy. Before that, I was working as a developer relations at permissioned enterprise blockchain at R3, and before that I was engineer for like 8 years, like backend engineer. And before that I was research sciences, and was doing research at in queuing systems and probability theory and signal processing. So yeah, and I really enjoy protocol labs because engineers are very, very smart, and it's a great kind of team. It's a great culture, and everyone's super friendly, and I learn a lot. So I'm quite happy. So yeah, I'm also hiring.
Well, that is a fantastic pitch, and I can attest that the Protocol Labs team is fantastic. I'm good friends with David Ronjic over there, who I think is a key part of the Baechle efforts. And I think he may have actually been my first boss, technically. It feels like a million years ago now. But your experience is actually quite interesting. Both those other technologies you mentioned, Mina and R3, are super famous projects. I hate to be taking time away from Protocol Labs, and please feel free to share any of the questions, audience, just raise your hand. But I find that like one of the challenging things about our whole space is there really a use case that is super compelling for these really interesting technologies that you mentioned? And I know, zero knowledge proofs are really in vogue right now, and there's a lot of interest in what's happening. Were there any efforts that you were involved in at Mina that you'd like to chat through? I gave my little demo earlier of how we're using zero knowledge proofs at Weavechain to debug a data set that you can't see, but it's still an exploratory effort.
Yeah, Mina is great. The idea is fantastic, and so the idea with the Mina that you have this like you have a blockchain that is a proof of a blockchain that is 22 kilobytes, and when you run your smart contract, zero knowledge smart contract, they call it like ZK app, on your browser, and only send proof of your computation to the network. So that's why it's quite cheap in comparison with other kind of layer one solutions. And the other advantage with Mina, that data doesn't leave your custody, so it stands on your machine, and so there is no need to think about where you store, how you store. But obviously this means that the data cannot be like very large, right? So you're limited to your machine. But in advantage to run Mina, that you can run it on your smartphone because it's so lightweight. So
almost the opposite of the 20 petabyte computations that you guys are tackling over at Protocol Labs.
Yeah, exactly. It's like it's kind of you see it's kind of like different use cases, right? One use case that you don't want to share your like small piece of data because it's quite sensitive. For example, as one of the gentlemen mentioned, healthcare, and you just like share with your doctor or with the hospital a proof that you're eligible for some sort of treatment without actually showing your medical records. And this is like one example, but we all know that medical records are not like usually are not like 22 petabytes of data. So another use case, like for Baechle, is data scientists who would love to collaborate and verify some of the research, some of the paper that they read, and they would like to build on top of it. So research on top of that paper. So they they know that the data is online on IPFS. They can easily run computations. They can send their job, their kind of algorithms, assumptions or theories to the Baechle to run it over the data. So which is public, and yeah, so it's kind of like completely different use cases. It's been like super exciting to work in both of these organizations, and R3 is developed this permissioned blockchain, which called Corda, and it's more the use case is more for the kind of enterprise organizations where you don't want to share your transactions. You don't want to share even like hashes of your transactions with anyone. So obviously you think of like investment banks, etc. So it will store on the transactions. It will store only on the ledgers of the participants in that transaction. So it's because we all know that currently data scientists kind of did some research on the data, on the hashes of the Bitcoin and Ethereum, and it's possible now to identify identity, even if it's private. If it's hashed, everything we can identify where the locations of the person who submitted transaction. So it's not as private as even if it's hashed, and so the use case for the Corda is beyond the private. It's a private financial institutions and organizations.
I love your career progression. You've gone from fully private and permission networks like R3 to some of the zero knowledge stuff at Mina that can be put on public chains, and now promoting public goods and open science at IPFS. It's your path to decentralization, so to speak.
Oh, and, thank you.
You mentioned a really interesting use case that came up actually in the hall earlier as well. Somebody was mentioning, could you go and prove your COVID vaccination to somebody else without revealing any other bit of information? And this is a really classic example that zero knowledge proofs could be used to go and maybe utilize that verifiable credential pattern that I mentioned earlier, where there's some authority like a hospital or even a Walgreens that attests that they gave you that dose. And then you are going to get that presentation and present it to somebody else who can validate it, again, without knowing any other information about you. And, what I'm seeing in the space is that we're seeing a lot more tools becoming available to people that want to remain anonymous, but still be accredited in some way, shape, or form. So, maybe I could go and I was chatting at the Polygon conference in Paris with somebody who was talking about doing journalism in, countries that are at war, where if you're the person that's actually taking photographs on the ground and presenting information, you're actually putting yourself at risk from, attack from a sovereign state. And, this privacy preserving technology, I think, has a lot of potential to enable people to, be confident that they can participate without having ramifications of their actions.
Yeah, definitely. It's a great example, some great use cases. And also, this is a part of that, like protocol apps and IPFS kind of theory and aim is to break down this like data silos, that it's data, that how much data is being harvested on all of us by big tech, and giving it back to the humanity, giving back to the data science, give data to data scientists, make it public, not data that harvested on people, but kind of humanity, good for humanity data, and making it even allow this kind of allow working together with just hello?
You're still here. Sorry, I was trying to get you on the big screen for everybody. I should have done this moments ago.
Yeah, allowing collaboration between scientists and allowing more research and more theories to be validated and run on the data. So yeah, it's a next stage of the whole decentralized science, making it possible and easier for scientists to run research, to validate it, to verify it, to collaborate, and to share the data between organizations and between the borders.
you mentioned the use case of a journalist on the ground going on and getting the stuff out there. On the other hand, it turns out if someone wants to go on and break into the defense department, publish all of the secrets that they're never caught, it's a great opportunity to do that too. So all of these things pretty much are value neutral. They're all simply technologies for making this particular kind of data sharing happen. So this will be something that probably comes up pretty quickly, I would imagine, if this stuff gets, you're looking for a use case, this is one somebody would pay for.
Beautifully said on both fronts. It's an exciting time. Well, Iryna, thank you so much for sparking that conversation and for giving that chat today. Let's give her a round of applause.
So my name is Jordan. Thank you for the opportunity here today. So this presentation is on the decentralized funding for science's final frontiers, and that is frontiers plural. That's not a typo, and I kind of kept that ambiguously vague to make sure everyone came back from the break and didn't leave early for lunch. But since whoever's here is here, I'll disclose that for the sake of this, the final frontiers are human longevity and space travel. And these, at first glance, these may seem totally unrelated, but these are two largely underallocated areas of science by legacy financiers, and they may be more interconnected than you think. This niche area is futuristic, Web3 friendly, and has a big following and ripe for the dedicated collaboration of a DAO of its own. And this here is a boiled down kind of map of what we're going to talk about today. I'm kind of committing the cardinal sin of telling two stories at once, but please bear with me. So there's a science problem in space health and human longevity. They're both underfunded in emerging fields that will have increasing importance and impact on human life as with time. And then there's the science solution for that, which is the Consortium for Space Health and Human Longevity. There's a big funding problem in that both of these are new fields with historically low allocation that's not increasing anytime soon. And then we're hoping to create a funding solution for this using the SpaceDAO. So I'll kind of give a brief introduction on both of these science problems, talk about the science solution, a brief discussion about the funding problems, and then the funding solution. So we'll start here with the space health. So space is a hazardous environment. It's challenged by many novel exposures as well as the lack of luxuries here on Earth. These hazards have many health consequences, as you can see here, which have clinical manifestations through this collage of insults that result in many forms of disease. So here we see some of the diseases resulting from spaceflight, including muscle atrophy, heart atrophy, leaky gut, bodily fluid shifts, neural and cognitive impairments, immune dysfunction, inflammation, kidney stones, and bone demineralization. Now, many, but not all of these are also considered age-relating diseases, except they happen at a far more accelerated rate in space than here on Earth. This presents a huge challenge for deep space exploration, multiplanetary species, but where we need to live longer, not shorter, to make those human accomplishments. But it also presents a huge opportunity to study aging at an accelerated pace, since aging studies on Earth are largely limited by the long follow-up study duration needed to achieve clinical endpoints, as well as to achieve statistical significance. So for the more numerically inclined people, as I would suspect many of you are, this is a table that has more detailed rates of aging on Earth and in, space aging and Earth aging. Now, this is an oversimplification here is that you could say, on average, these systems age at roughly a 30-fold increase in space or in low Earth orbit compared to on Earth. Again, this is an oversimplification. Some of these pathways and systems are more influential in the aging process than others. And there are many countermeasures and compensations, both physiologically and behaviorally, that can dampen this effect. But I digress. We're here to talk about DeSci and the opportunity here. So there are some these are both kind of exploding industries, the space economy, as you can see with the rise of commercial spaceflight tourism, space hotels, et cetera, as well as what many consider the silver tsunami or the aging demographic of the world, especially in developed countries. Now, despite these trends, NASA only allocates about 1/3% to biology and physiology research. And I understand why. Like, if you can't get to space, it doesn't really matter how your body's going to react to it. Many of this budget is almost entirely engineering. And I agree, it's for a good reason. But the problem is that astronauts suffer all of these. Astronauts have significantly lower lifespans than their Earth counterparts. And there are many risks and questions that remain unsolved. On the other hand, the NIH only allocates about 0.5% of total budget to fundamental aging research, despite about 80% of all deaths in the US attributed to aging-related pathology and disease. Furthermore, if you submit a grant for space health to NASA, they'll say, oh, this is a health problem, submit it to the NIH. If you submit it to the NIH, they say, oh, this is a space problem, submit it to the NASA. I mean, we've been playing this cat and mouse game for quite a while now. So I think that this creates the fundamental opportunity for a DAO to both kind of address this unmet area in science, as well as expand it to new and upcoming scientists exploring new areas. So this is how this is how kind of legacy financing goes in science. You have, well-established scientists and well-established areas promote or kind of advancing their hypothesis, their dogma around a certain disease, pathway, molecule, etc. They have preliminary funding from previous grant that they use to apply for grants. They outcompete other grants because they have preliminary funding. Then they incrementally advance that field. Say you're a new scientist or the science transitioning from one area to a new area, or trying to start a new area of science. You don't have that discretionary funding. You don't have that preliminary data. Ultimately, your grant gets rejected over and over again, and the field never develops. The field never advances. There are no real moonshots in science. They are just basically confirming what has already been found or advancing what the grant committee really is invested in. So this is why we have largely developed the Consortium for Space Health and Human Longevity. What is it? So it's kind of a mouthful. So for the sake of this, just to speed it up, it's CSHL provides funding for labs affiliated with the consortium centers, as well as individuals interested in contributing to advance the understanding of the intersection between space and aging biology, with an emphasis towards translational research. So again, here it's at the intersection between spaceflight pathology and geriatric pathology. And we hope to roll this out in 3 phases. First with mostly the US, and then expand this to North America and Europe, as well as then go globally. We kind of have to tread lightly doing this because there are several types of restrictions around who can have access to NASA's data and how those funds can be distributed, etc. So we do have to kind of roll this out in phases and be very cognizant of those restrictions. Right now, we have about 6 institutions involved with the consortium right now. As shown here, we hope to expand this more towards individual contributors to address some of the problems that we're facing that I'll talk about in a second. So this is housed actually at the Buck Institute for Aging, just north of San Francisco. So we actually have some dedicated lab space for this that we hope to expand upon recently. So what is it? We have frequent grant cycles, a network of diverse expertise, annual conference and retreat, investor networks to hopefully spin out some of the innovations into startup companies, clinical and advisory boards to fine-tune experiments to have the most translational impact, and collaborative databases and biobanks to verify some of the findings for ground analog experiments or spaceflight experiments, etc. So the IP from spaceflight engineering has really not only spun out into several companies, but entire industries in general. And this is largely from the large engineering budget that we talked about earlier. Everything from solar panels to Velcro to MRIs to smoke detectors have all come from NASA technology. Some of the largest unexpected ROIs from government funding have been from NASA. And I think there's an equal, if not larger, opportunity for space health and biomedical research to advance healthcare on Earth, particularly in the longevity field due to the phenomena that we talked about earlier. So the type of IP and the type of projects that the consortium in the DAO are mostly going to prioritize are both research tools and patient and crew care. So just to talk about research tools for a second, a lot of these were developed in the 80s ish to basically evaluate the impact of microgravity on genes, et cetera, and kind of archaic type biospecimens. There's huge opportunity here to modernize some of these approaches for human organoids on, or organoids on a chip, and all kinds of assembloids, et cetera, to kind of bring this into the modern era. So on the right here, we have a rotary cell culture, which basically spins biospecimens to create a net zero or microgravity force. That one with the squiggly line, that's a random positioning machine, which basically spins specimens in a random to create another type of vector force. These need to be kind of modernized, and we spent a lot of time on doing this. And I think that this would be a great way for people interested in space medicine to contribute from an individual perspective with 3D printers or CAD design, et cetera. There's also this opportunity for miniaturizing lab equipment for in-flight experiments, as well as kind of designing experiments for recording and monitoring cells in microgravity experiments. On the right, we have, these are just kind of projected areas of innovation. I don't think anyone foresaw the development of Peloton or anything from previous spaceflight experiments, but these are kind of what we would project the advancement of telehealth, advancements in osteoporosis, risk assessment scores, exercise equipment, and even drug discovery and wearables. So we actually had a first spin-out company from this consortium in the collaboration called Cosmica Biosciences, just to give like a brief example of this, which studies mostly immune aging in space. It uses drug signatures from analog experiments and then verifies these with in-flight astronaut data to develop gene signatures and identify drugs that can reverse those signatures and then advance those for investigating longevity on Earth through clinical trials, on Earth. So the leaders of this consortium would be David Furman, Cheryl Nickerson, Ashton, Dr. Weiner, Mason, Eric Antonsen. These are the formation of the consortium to kind of increase awareness of this area and kind of bring funding to some of their own labs, as well as others that can advance the field. And then the advisors for this would be Yothia, Allison, and myself. And then we're going to hopefully do this through the SpaceDAO. So here, go back one second. So this is the centers right now. We hope to expand this in multiple phases, as mentioned earlier. I got an error, one second. So then we would obviously deploy these tokens to a cryptocurrency exchange for funds, which would fund the consortium. Project proposals from centers or individuals would be vetted by SpaceDAO stewards. Those would be voted on in the marketplace using tokens for which ones are funded, which ones are not. Those would be deployed to a smart contract, and the grants would go to the centers or individual contributor or proposal submitters. The advances from these would both benefit the SpaceDAO users through anti-aging technologies, commercial products or supplements. Then the intellectual property would go to the consortium, which would have some bargaining power over the licensing deals for these. And then those would go back to support the consortium and the token holders. And so the SpaceDAO community, I think having a DAO is very much very similar to starting a community. You need to make sure everyone's engaged and it's worth their while. And so we hope to have annual meetings, healthy aging coaching, extended podcast series, extended webinars to keep their interest. And obviously, also we've been looking into kind of doing more decentralized science with the contributors, whether we find through the saliva test we do with astronauts that a certain molecule is increased in space. Does that actually correlate with aging? We can send out test tubes to the group and pull this together and keep everyone engaged and supporting the DAO in general. So this is kind of the stages we're at. We have the formation, and we're doing a capital raise and the tokenization of the DAO. We hope to have an official launch in January and then start the first cycle with the first phase, and then increase the recruitment with each grant cycle and roll this out in an organized manner. So like I said, January 2023. And thank you for your time, and I welcome any questions. And this is my email or Twitter if you have any other questions. So thank you for listening.
Jordan, that was fantastic. Does anybody have some questions? Start over here.
So this isn't exactly in the subject of DAOs, but there's in general in medical research, it's sort of a truism. There's lots of ways to break things, and not necessarily. And the fact that you have two broken things next to each other, it doesn't imply that the cause is the same. So you can break people by putting them in space, and you can break people by letting them live too long. How do you know those mechanisms of breakage are the same? And that's sort of my question.
Right, absolutely. So I think one of the measurements on here was that heart rate decreases in space, right? You can fall asleep and your heart rate decrease. That doesn't mean you're sleeping with age. You can take drugs that decrease heart rate. That doesn't mean you're sleeping with age. But it's actual mechanisms of aging that are actually pathology, like osteoporosis, muscle atrophy, are non-transient. They do have the same mechanistic signature of the pathology on Earth. And we can see this through the multi-omic analysis of the astronauts. So I agree that there may be some slight differences in that, but largely the driving mechanism of this pathology is actually currently being fleshed out in the multi-omic analysis. It used to be kind of what you're saying, that these are true, but unrelated. But we're finding that on our microgravity experiments in-house and in spaceflight, we're seeing a large degree of overlap. And right now we're trying to tease out what is the actual space hazard that causes this. So I think a really interesting aspect of that is mental health. So astronauts go into confinement and they lose neurocognition. So they think slower, things happen slower. But is that actually is that radiation? Is that microgravity? Is that fluid dynamics? Is that buildup of pressure in the brain causing the brain to slow? Or is that just the lower social engagement that they have? So we're actually doing several experiments, kind of adding an exposure one at a time to see what one is it.
So the bottom line is you're checking out the cause.
Right. In a word, 2 words.
Variable isolation, challenging for sure. Another question up top.
I understand that you're introducing a DAO for funding reasons, and can you just discuss like what considerations brought you to that choice?
Right. So funding and governance. So as I'm sure people know, is that academia is very political. So bringing together 6 institutions to collaborate on something that's all important to them, but let's say each of them submit a grant to this consortium. Do we just say, oh, all the contributors get 1 grant? Because then you're really only competing against people in your lab, et cetera. So I think the DAO would also allow for people to guide the science in a meaningful direction. So it's kind of a way to also do customer discovery. You want the science to impact the people on Earth here. So like, just because one of the institutional or the proposers is interested in that doesn't mean that that is going to advance the field necessarily. So the DAO would also be a check mechanism to make sure that the consortium goes in the direction that is going to impact people on Earth too, and not just do science for science.
Bill?
This bears a remarkable similarity to my interest, which is basically putting together a DAO for rare diseases and having the patients themselves be the stakeholders inside this thing. So the point I want to bring up is, as you put this structure together and figure this stuff out, there's a lot of alliances out there that potentially you can build up besides just aging and space. There might be rare diseases, in fact, that you could go on and act as a beachhead for in terms of putting the structure together and maybe share resources. So
right. So just today they started an experiment for increased pressure in the brain for testing a medical device in space for hydrocephalus patients who have kind of poor shunts in their brain that cause increased pressure. So I think there's definitely an opportunity for that.
Maybe I can actually follow up on that one. I'm always so curious about this. Is the DAO effectively like acting like a venture capital organization from that perspective? And if so, what do the economics look like for, the people that purchase that token and are a part of the DAO? And then, the projects that you end up funding, do you end up owning a percentage of the IP in those? And is that transferred back to those token holders?
Right. So this is something that we've talked about pretty heavily. I'm just going to pull back like one slide or two. So on this one, I kept it vague here because this is something that we're currently negotiating. NASA does not want people outside the US owning their IP. That is a hard stop. So we're thinking about negotiating the IP and adding the value to the tokens, through airdrop, pay, etc. I would love to do an NFT token, but the decentralized aspect keeps us from regulating where that goes. So that is something that we had to consider when designing this. So we think that we think the consortium will have higher bargaining power for royalty rights with pharma companies and device companies holding the IP and then distributing those royalties to the token holders.
That was a great answer. And I'll just follow up when I was chatting earlier about fixing identity, especially in these token markets. You need to sort of do things like KYC or make sure that somebody is in the United States or a US citizen, for example. And, we're following projects like Parallel Markets just released an NFT that they would issue to somebody that they have validated is a US citizen or an accredited investor or KYC'd appropriately, so that you could ensure that only those people are capable of purchasing your DAO token. And then, maybe you need to actually issue that token in a way that's soul bound to ensure that it can't be transferred to somebody else.
Yeah. I think that'd be hard to sell. I think it's a great solution, but it's hard to sell. So right now, this is kind of why why this is a dual presentation with the consortium and the DAO, because these institutions, there's nothing academics love more than a consortium. They get on each other's papers, they collaborate, they get more publications out of it. So we basically say, you want to join this consortium, all the IP goes to the consortium, and then they're like, they don't really care where the funding comes from as long as they get funding. So we kind of formed the DAO to fund it and kind of automate the whole review process as well.
Super interesting. Thanks for that. Great. Sorry, could you introduce yourself before you ask your question?
My name is Pavel Novichkov. I'm from FenaBiome. So my question is actually on the technical side, when you create this DAO, do you use some kind of platform or develop it from scratch?
I personally do not want to build it from scratch. I'm a scientist, or like a biology scientist. So I would really like to partner with like BioXYZ or Molecule. I've applied to them. So if you know anyone here, shoot them a text. I think my application's somewhere at the bottom of the pile. I'm sure they're very busy.
Vincent sponsored, so we'll make sure to make that connection afterwards.
Thank you.
On the side. And again, if you could introduce yourself, that'd be great.
Ron Van Maden, UNSW Sydney. So how are you managing the sort of review process for these project proposals, given that the token holders may not be scientific experts?
Right. That's a great question. So I know this diagram is very complicated, and I tried to simplify it as much as I could. But these DAO stewards would largely triage the proposals to make sure that they're in line with the mission of it. And we hope to make their reviews of the proposals public. So we could actually allocate experts to this, and they could say, we think this might work, but these are the challenges associated with it, which make it, high risk, high reward, or low risk, low reward. So then people kind of can frame their understanding of the project from a review, somewhat like a Yelp review or something like that. Because yes, very, like I said, very few people are experts in this area. Yeah. Yes.
Just a moment.
No, sorry. I shouldn't be.
I appreciate it.
Hi, my name is Miriam Zandy. I'm with TrueBlocks, which is an Ethereum data indexer and explorer. I don't know much about DAOs, but I know a little bit. And it's still very much early days. And some of the bigger challenges with DAOs tend to be around governance and engagement from token holders. So I'm just curious, sort of, is this going to be a permissionless type of situation? Is the DAO, are the DAO token holders going to be anybody who's interested, or are you limiting it to a certain type of individual?
So in a word, we want it to be everyone. and I agree that that can lead to bad actors in the field, and that can lead to someone buying up all of them and dictating the entire consortium. There are ways to, which I'm sure many people here are aware of, so I don't want to, totally botch this, but there are ways to address the governance problem and say at least this many number of people need to vote on a certain project, increase the persons per vote, or you can also cap it at, a majority plus a certain amount to kind of increase the unity around a decision. So it's not just major token holders. And what was the other question? Oh, so we also want to have, I think that a big problem with maintaining the engagement is to do kind of maintaining that community and having annual meetings, offering perks to holding the token, not just during voting, having extended podcast series and, explaining the science, explaining progress to those interested. Does that answer both your questions?
Still pretty early days for a lot of these DAO governance models, but the exciting thing is that people are experimenting with new governance models, whereas let's say equity systems or even most, democratic voting systems haven't changed in 100 years.
Right. Yeah. We've never really questioned, what if a bunch of people got together and voted for a certain government candidate, but now we're actually questioning it because you're designing your own kind of government structure. And what if, a project just creates a really clickbaity, kind of title for their research to get funded, and we've been dealing with this, but we've taken it for granted. We haven't really addressed it, outside of the DAO. So I think it brings to light a lot of questions in society in general.
Really fantastic questions. Does anybody else want to ask to Jordan? Please.
I guess maybe the final question is, given that you're doing this for NASA in part, and you've got these constraints of needing to be in the US, what's your sort of corporate structure for this? How do you fit into the legal system?
Right. So we're open to DAOify it through the state of Wyoming, and then have the consortium actually be a nonprofit. I would just, have a quick answer for that. I think that's really the most of the paths. This is a very, path less traveled, but of those, this is the most weed whacked, I guess. I don't know. Okay.
Really good question. Weavechain is currently a C corporation, but that path to decentralization, I think, is the whole thing. It's like, how do you work your way there in a way that's smart?
Yeah.
Jordan, we have a few minutes left. Maybe you could tell us a little about your personal backgrounds. Sort of.
Yeah, of course.
How's your career gone before Web3? What got you excited? And
yeah, I guess I did kind of speed through that. So I am from Tennessee. I went to medical school there. After graduating from medical school, I was very interested in oncology, and having seen the difference between what patients were receiving in the clinic and what we were doing in our lab, I became really interested in translational medicine and how to bring discoveries and innovations from the bench side to patient care. So that led me to San Francisco area to do translational medicine at Berkeley and UCSF, which is kind of a merge program between business and bioengineering and regulatory processes around clinical trials, et cetera, and dealing with the FDA. In this process, I became really interested in kind of root causes and kind of discoveries and innovation, and translating those innovations at the very root cause of disease and cancer in general. So that kind of led me to the Buck Institute for Aging, where I'm doing a postdoctoral fellowship in inflammaging, or inflammation-induced aging, and space medicine. And that has kind of led me to, I'm applying for NIH funding. I have, preliminary grant, but there's not really anywhere to kind of the next steps for this. There's only kind of small grants for this type of thing, no R01s, nothing like that. So that kind of led me to kind of in multi-institutional collaborations using their discretionary funds to advance my research. But, that's not sustainable. So that's kind of led me here. And then, so this, instead of, sitting around and complaining about how there's no funding, I'm just going to go do something else. I'm trying to, create that space.
That's incredible. And then, and then how about with Web3? What have you been up to, that led you to this model? And
yeah, well, I've applied to, like I said, I've been applying to NIH funding for a while, and got really frustrated by the process because, you submit a grant, you get very, very little feedback. You just score back, basically says apply next year, apply to a different institution. And then I applied to actually VitaDAO. And I don't know if anyone here is from there, but if you are, thank you. Because like they just emailed me and just said, oh yeah, like we had a question about your application. We want to hop on a Zoom call and talk about it. And I was like, oh my gosh, this is amazing. Like I'm just used to getting rejected over the course of 4 months with like no feedback and no one asked questions, like, oh, you want to like talk about this detail of it? Great. Awesome. I'm happy to change it, so that kind of like led me towards a DAO and kind of realizing how decentralized and kind of, non-legacy forms of financing and how to incentivize that structure, I found very intriguing. So I wanted to learn more. So here I am.
So cool. It's, really a community that's making a lot of these things happen, that human interaction. And I just want to thank you for being a part of this today and sharing your experience with us, because that was fantastic.
Yeah, thank you.
A lot of different things, which I'll get into later, but first I want to talk about what's inside this wiki. The first thing is a set of standards. So just a wiki that summarizes the state of the art of the field. So problems, approaches, solutions, the description of the field, the summary of the state of the art, etc. A Git control repository of everything that's relevant to the development of this field. A forum with customizable channels for any kind of discussion. And a set of child frames which are each investigating a specific part of this field. So standards, this is the wiki I was talking about, include the following pieces of information. Like I just said, description, summary, list of subframes, which are just child frames, list of open problems, and for each problem, a list of approaches to that problem. Anyone can fork a standards document to create a new frame or subframe, which basically means we can capture the state of the art of a field, and then anyone who disagrees with a particular part of it can fork it and go in their own direction. Anyone who wants to investigate a more specific issue within that frame can create a child frame. And every normal scientific action within this framework enters the knowledge graph according to a unified ontology. So again, why are forkable wikis useful? Everyone can see the state of the art of the field at any level of specificity at any point in time, which means you can see exactly what needs to be done, what has been done, and where you can help instantly. This is really good for onboarding into and between fields. A lot of the sort of makeup of our disciplinary silos are just like the lack of explicit information about entities or fields available to anyone who's not been an expert. So basically what you go through in grad school is building this sort of mental map, which is naturally created by this, of just like, what are the problems, what's been done, what's worked, what didn't work, what needs to be done, what are people doing, etc. If we can make this explicit, anyone can see it instantly and then start contributing. So what things can be a frame? Recap, a frame is the sort of wiki concept I introduced earlier. Fields, subfields, subfields, etc. Problems, approaches to problems, methods, concepts, and theories. Basically any entity that requires a definition in relation to previous knowledge and is the subject of collaborative work by a bunch of different people. Yes. Communities can be built around frames. One definition of a field is just a group of people that's working on the same problem. Usually a lot of the market inefficiencies that come from this process derive from the fact that the people working on this problem have different incentives. So private labs want to keep their research private and competitive advantage over all the other private labs. Academic labs want to keep their credit so they can publish and get credit later on. Independent researchers don't have a lot of money and don't have a lot of resources. So sort of like gradient with very extreme poles of experts, grad students, and laymen, and the difference between literally just how well have you defined this mental map in your head. The cool thing is, a lot of you guys have probably talked about so far, with Web3 protocols, we can enable collaboration between these groups in the form of granular contributions. So like TLDR, anything you submit, whether it's code, notes, opinions, papers, micro-publications, reviews, whatever, you can get credit for this and link it back to your wallet, which means we no longer have to publish giant papers through giant journals and have it take 2 years to do peer review. Yep, everyone gets credit for their work. So here's a concept that may be a little bit difficult to explain. Feel free to ask questions about this later. But basically, there's two ways I'm focused on of getting new ideas and building on existing knowledge. The first one is recombination of existing ideas, and the second one is a more specific exploration of an existing issue. So both of these things can be defined in the wiki document, and then approaches or new frames can be linked to those. Basically, you get a network of forks, merges, and links, which builds a knowledge graph, which can be traversed by an AI, which can continue building the knowledge graph. Yeah, so here's a way to sort of, I guess, grab papers on the internet and tag them according to frames. So each frame becomes a tag within the Halogen network, which essentially means that, like, if I create a frame, which is like a field, and let's say this field is, I can go on the internet, go on archive, and pull up a Chrome extension, which basically lets me, like, looks at the semantic content of the abstract, the title, and the authors, looks at what I've been engaging with in Halogen in the past, and recommends a tag. If I select this tag, it adds the artifact directly into the, adds the artifact directly into the frame, which basically means each frame or entity in the knowledge graph is populated with a lot of specific information from all over the internet at any point in time. Yeah, so here's the cool thing that can be enabled with DeSci. This is just that, like, tag documents can be turned into knowledge artifacts, which have a state and a persistent content identifier and can be indexed in an open state repository. Basically, if any of you guys have heard of DeSci nodes, this is one thing they're focused on. We could, with Halogen and with DeSci Labs, we can turn anything into a DeSci node, not just a PDF. Like, again, code, notes, opinions, reviews, comments, etc. Everything can be given a persistent state identifier. So the cool thing about this is that if I do something, it's given a name and it exists in a network, and anytime anyone copies this thing, replicates this thing, or does a similar thing, it's linked to this one place in time, which means we find out what worked, what didn't work. We basically have a representative knowledge base. So things Halogen can do. I like to summarize it by calling it Web3 data, which is unified ontology for knowledge graph from, like, a lot of different information by just providing unique identifiers for entities, and these are frames. But things it can do practically are like enabling polymath projects, creating a market for tacit knowledge, and I'll skip over this one for now. Yeah, so like I just said, granular contributions enable us to or through, like, linked approaches between objects which each have their own. Basically means, like, if you create a knowledge artifact and I cite that artifact and your thing later proves out to be wrong, through decentralized review, for example, that information is communicated to me. And let's say this chain perpetuates itself across, like, any number of links or something, updates will be probably of those links. Yeah, should I talk about this? One thing that's useful in biotech right now, or one big issue in biotech, is that people's, like, opentrons or lab robots have protocols that they all have to write themselves. So there's a lot of reinventing the wheel because everyone's keeping everything secret. But there are some, like, low-level pieces of information, like whatever the molecular equivalent, that can be shared for biotech. This would be useful. Yeah, I can skip over this. Decentralized peer scale. So if we have this wiki structure, we can forms for a field. And if you think about what peer review really is, it does this look like it's in accordance with what we already know? So if in the standards that I described earlier, we've defined what we already know, how to, and then we can just diff check basically against the sum of what we know, diff check a new knowledge artifact against the sum of what we know. So we can review really quickly, allocate it, and also make it semi-automatic with language models, because we're literally just checking semantic content. Does this map or does this not map? This is like not necessarily checking for like anything like that. It's just like a quick yes no check. But so one thing you can do if you have this tagging system is you can create a sort of attention overlay where you're looking for every instance of a given artifact on the web, how much attention people are paying to it. And if you can have wallets, you can say, okay, this person's an expert, a lot of probably good. You can do this to quantify how well looking to fund something, you can see what people are paying attention to and say, okay, this is creating a lot of citations, or okay, people are paying a lot of attention to this, in a way that's completely separate from the journal ecosystem. Polymath for problems with unclear solutions. So the core idea here is, sorry, the first time this implemented was, and how I think, where they like created a math problem and on their blog and said, okay, in the comments, people should post partial solutions, ideas, and approaches to this problem. And they solved it. And they did this again a few more times. The cool thing is, I think this is applicable for, this sort of framework is applicable for many more things than math problems. And if you have a network where people can define the sum of what we know, define problems, you can like mark something as an open problem and different people can create different approaches to that problem. A funding DAO can put a bounty on the solution to that problem, which basically means like any kind of problem anyone's having can be solved in a distributed way, using expertise from a lot of different places. Yeah, that seems to be it for this. Oh yeah, the other cool thing is private labs and academic labs who, like I said, don't want to share all their work, can partially open source problems they're having to other people in this network without revealing all of their information. Just because since there's unified ontology, they can like publish part of their frame and say, okay, we're going to pay you guys this much to solve this problem for us, and it can be solved in the polymath method that I described earlier. Yeah, solved without revealing everything, which basically means anyone can partially open source anything they want to. And when they're done, a private frame can be modularly published to the public knowledge base. Right now, this is impossible because every knowledge graph looks very different from every other knowledge graph. But if things are done in a sort of unified way, we can have composable knowledge graphs, basically, where like I can create something on my own and then push it to the public network. People can work directly on the public network. And the sum total of this work means that we can eventually train a language model should traverse this network and generate new hypotheses, approaches, connect deeply related concepts that humans can't see, look through giant volumes of data and find what's related, what's not related, basically superpower our knowledge base. This would enable a superpowered knowledge base or AI rig design. Yeah, so just to reiterate, the way you'd interact with this is defining a problem in relation to what we know already, which is the sum of all knowledge that I described in standards. Collaborate safely with everyone who's working the same problem because we have granular contributions linked to your wallet. And the result of this is a knowledge graph that's traversable by an AI. That seems to be it. Okay, I'm not sure how much time I have left. I guess I can take questions now. If anyone has any.
Of course. Jeanette, please.
A few slides back, you mentioned that you could see what people are paying attention to, and how do you view that? Is there like wallet connected to these nodes, or how can you trace what people are paying attention to?
Wallet connected to these nodes.
Or how do you know? Because you don't know them by name, right? You're just saying.
So okay, so I should clarify.
Okay, attention overlay. Yeah.
This is starting out as a Web2 project.
Oh, okay.
Yeah. So
okay.
It's more like people are paying attention to things on Twitter.
Right.
Like Twitter is like a discussion platform for archive, right? Discord is sort of a discussion platform for archive. You can look at these things and trace like the literal piece of semantic information through these private networks, or I guess they're sort of public networks, and see in sort of a more manual way at first who's paying attention to what and what things seem to be discussed in what ways. This doesn't necessarily have to be linked to like, we know who you are and we know everything you've looked at and we're like tracking you. And I hope it doesn't turn out that way.
Right. Well, it is AI. That's why I was
Yeah.
wondering.
I will say that the AI is mostly going to be used for generative modeling, like just generating new things. Not so much tracking people.
Okay.
But at some point, I'm very much open to evolving wallets directly and linking them to people. And like once more pieces of knowledge start moving directly onto this network, we can start tracking things in a more holistic way. But until there's enough information on this network, it's not possible.
Okay. Thanks for clarifying.
Are you familiar with akasha.org? Akasha, Akasha, I think it is. Okay. And then also, and how about Protege? Those are three things you might consider looking at. You can ask me later.
Luke, can you provide any context?
Oh yeah, great idea. Context.
Bill, what is present context on what Akasha does? Or
Sure. Well, they basically, my daughter gave it to me and I read through all of it. And it's near as I could. So, well, all right. Those of you familiar with Hermann Hesse's glass bead game, it wound up being a formal mechanism for organizing knowledge, and it was published in the 1930s. This guy was inspired by it, came up with a wiki approach to do this thing, but and allows you to go on and connect and reconnect knowledge throughout this entire wiki. PsyCorp was established originally back in the 70s. The way knowledge was organized was in terms of a rule systems. The rule systems wound up reaching an epitome with a company called PsyCorp based in Austin. What they've been doing for the last 30 years is taking common, ordinary, everyday knowledge, putting it inside this thing and allowing an AI to go on and generate new concepts from it. Protege is a project out of Stanford. It allows you to go on and create and maintain your own ontologies. There are a lot of them out there. And in fact, they could go on and be and they could go on and be joined together into this kind of structure you're talking about. So there's a lot of, I at least am familiar with these three, and there are more out there, mechanisms of providing hierarchical structure on top of knowledge and having an AI walk over it. It might prove useful to you in your project going forward.
That was great, Bill. And I'll just mention as well, like I think fair data principles are all about trying to structure data in a way that's more interoperable, that follows that standardized ontology, so that you can do a lot of these really cool, interesting things. So kudos. Please.
Hey, couple things. One is around the incentive structures of contributing to the project. I guess I'm wondering, obviously Wikipedia has a tremendously successful model where there isn't really an incentive structure per se, other than like, I'm feeling altruistic and I'm going to contribute. But for something that's seems to be just start off a bit more, other than this is the history of the hamburger, something a bit more intensive to formalize an ontology and connect it to other things. So I'm wondering around the incentive structures that you're going to build in to encourage network adoption. And then completely unrelated, but how do you view the, I guess this is more of a philosophical question, the concept of knowledge per se, of like, like pure mathematical concepts of knowledge are maybe not refutable, but a lot of other concepts, there are people, theories of the mind, theories of, anything above that. There are people who think the 100% opposite, and especially in context of economic theories, political theories, philosophical theories. How do you deal with people who are like, Israel versus Palestine, objectivity versus subjectivity?
Right? It's like summarizing what we know and then arguing about what we disagree on. Right? This is like the core reason I've been talking about standards, which is just like, sorry, I should have clarified this in activism, which is like, we can separate total bullshit from disagreements in terms of how much it links to what we know already. Knowledge becomes more established the longer it exists, right? And this is something that's quantifiable to some extent. Which means basically, you can imagine as work proceeds, by the way, I'll get to your first question. Remind me what it is after I answer.
Sure.
Yeah. Yeah, but if we can like by naturally running this engine, like by people publishing things in journals and on our and we're putting this into a summarized document of what we know, and this is reviewed by experts, just like a textbook. That's actually a pretty good frame to think it into. And anything new that's built on this textbook is linked back to the old one. Let's say I completely make something up and it doesn't link to like the basic principles of physics, right? This is an easy way to tell this is bullshit, right? But then there's the disagreements about like, I don't know, mRNA vaccines, right? Like there was a scientist a couple years back who, what did she do? She discovered some new technique for creating vaccines and everyone disagreed with her, right? But if she could have linked her approach to what she knew already and everyone agreed that this was known, it's not total bullshit then, right? So the key idea is just like defining what we know, working that, and creating new approaches that are now linked to what we know already. The first, I think your first question was about incentives.
Yeah, incentivization of adoption and participation in the network.
Yeah, so the way I sort of think about this is I'm very open to like learning about new incentive mechanisms because Web3 is not my area of expertise. But I will say that like the system is designed in a way that's amenable to the way that work is already created, right? So if you're just doing what you already do in the public archive and discussing stuff and summarizing those things, of science, right? If these be put into a knowledge graph that's has a very standard ontology, it's not that you're contributing directly to this project, it's just that you're doing what you normally do, and it's structured in this way, like magically, basically. There are a couple people that'll need to like validate things and write standards, but these are the same people that write textbooks in fields already, like Goodfellow for deep learning. There's someone like this in every field or for every entity. Those people are, I believe, just happy to do that. But definitely would be useful to think more deeply about like direct incentivization.
In terms of grounding of knowledge, there are a couple of things you might look into. One's called superwater, another one's called cold fusion, and the third one that you might want to look at is reproducibility in science. There's an argument being made now, especially in biological sciences, that 80% of the reported results cannot be reproduced. There's another place called alltrials.net that you can look at where they discuss in particular the problem even of reporting the information based on stuff that's done. So I cry when I go on and look at this because I think this is the way it should be, but it's not. That is, a lot of the results that are out there you cannot trust. You cannot go on and trust the results that come from unsubstantiated sources, and worse, you can't trust the results that come from substantiated sources. And one of the key problems that comes up is nobody has budget out there to go on and try out the experiments where breakthroughs have been reported and just test and see, in fact, whether or not it's bullshit. So, and also in terms of writing the knowledge graph, Wikipedia recently had a scandal where there's this woman basically wound up meticulously putting in every sub detail inside of Wikipedia, drawing some false conclusions, and had it sitting there for, I think, on the order of 15 years until finally it was unearthed and uncovered. So again, understanding where this information comes from and validating how it fits into the real world is an issue with systems like this. Yeah. Is an argument.
Yeah, you're absolutely right. I've been thinking about it a fair amount, but I think we'll think about it a bit more. One of the things you can do is like verify identities of sources. Like if I'm Stanford's Filecoin Club and I'm posting something to this network, I have like my own frame, and let's say I'm the only one who can contribute to this. So it's not completely open. It's not that everyone can contribute. And if you create an entity, you can set the permissions for who can add stuff and who cannot add stuff. What I will say about reproducibility is like, if you're doing something on the cutting edge of a field, a lot of the approaches you try will not pan out, will not replicate. And a lot of this is just due to like, sure, like bad intent, bad incentives, but a lot of this is literally just like, you're doing something new, a lot of new things won't work. But if you can only get clear results from things that do work, I don't know, it's kind of screwed up. But I will say, if you have this sort of overlay of like theoretical context around knowledge, you can start to pick out What's the best way to put this? So sort of my view around this is just like publish everything, have it safely attributed back to you. And obviously most people won't publish everything, but if you can, and if you can have an agreed upon framework for what we know or don't know, with some degree of like, yeah, certainty, that's it. We can start to evaluate things, if we have this huge volume of stuff on archive, for example, but we have standards that we can dip check against, we can start to make sense of it in a low level way. It's not a problem that we can say, exercise extreme rigor on everything that comes into the system, because what ends up happening is you also crush novelty. So there's sort of these like design issues that you're dealing with. And I think the best solution to this is just have like a baseline knowledge base that's not very accurate. Have a baseline checker to make it a bit more accurate, and then you have journals that are like sorting out bullshit from not bullshit, or novelty or value from this. But the problem is you need the base layer to exist as well. Otherwise you end up with the system we have right now, which is not very good.
Natasha, maybe you could tell us a little bit more about how far Halogen at Cloud has progressed. Do you guys have a working product out there? Is it? Do you have partners that you're interested in working with for like your early stages?
Yeah, so no, I don't. I would really like some though. So if everyone has a potential collaborator, please send them over to me. Concept has progressed quite a lot since I started. I think 4 months ago, I started out with like a 30-page white paper talking about reproducibility issues and why I hate journals and why this whole thing is like irreducibly like fucked up. And then I realized this isn't a product. So I've been starting to work on a product. I have a working MVP that I don't think anyone's going to use. So I will say it's not quite, it works, but it's not great. That's where we are right now. I'm raising a right now I'm thinking like long AI research or yucky AI alignment research. Yeah, that's where we're at.
Doing research yourself that you think would apply to these things? Right.
I think I'm gonna start with it.
Sure. Well, so I appreciate it. And let's say the partners that you're most interested in right now. System.
Like an engineer that has expertise in language models or Web3 stuff. That's handled the whole stuff. I'm a bit out of my time. Yeah, I think the beta testers I sort of have access. I don't know how much time I have left.
8 minutes, but no rush.
Okay. Yeah, so when I was 16, my mom was diagnosed with like I don't able to create a cancer. Insane. Imagine what everyone had access to this and it was working optimally. So that's sort of how I got interested in this problem. I do remember having a lot of issues with like why entities or ontologies or like why isn't there a state of the art for a certain field of research? Why is everything that are flung? Started building out some different tools. One of them was like expert layman definition creator, where it was like I read a paper, I highlight something, I say I don't know what this is, and the expert's like, oh, you can pay me this much money to tell you what it is. Like a bunch of little things like this, which I didn't end up going with.
Urban Dictionary, was it Song Genius for science? What's the one that Lyric Genius? Rap Genius. It's one from Song. You have like certain lyrics from a song that are like highlighted.
Genius.com now, it's annotate the world.
Ah, there you go. Well,
fluid dynamics and and like, okay, what statistical methods are valuable? What like can we classify all of these things? And I remember reading these papers and being like, okay, I don't have the background to understand this, so I Googled this word. The Googled word would leave like this word college. And I remember so this surrounding as well, but fairly constructed. Yeah, for after. Bad to me. I think there are some other things as well. That tacit videos and like to build all my physics equipment. And it turns out it would be built on one.
Mentioned that one earlier as well, that there is no incentive to publish a study where the outcome was not what was expected, or it's considered a failure.
Yeah.
Do you have any thoughts around how you could do that? Because from an economic perspective, the investor always wants it to work, right?
Absolutely. Yeah. I will say one thing direct solution. One thing we can do is create a system that's separate from all the tangled incentives of our current system. It doesn't seem to be one we can exit from at the moment, right? So if we have a platform with a lot of respected scientists and a lot of funders and a lot of reviewers and standards for how all of these things are done, we can start to at least altruistically do some of these things and build in incentives on top of this platform. That's decent. Yeah, that is absolutely.
Just one.
Yeah, one other thing, this is something that I've been thinking about a lot for fixing kind of the problems that you are describing here, would be publishing your methods before you do the experiment. I think this would be a great way to someone to chime in and say, oh, I tried this, it didn't work. You should use this dose, not that dose, etc. And then it also allows you to kind of report your results more, it incentivizes you to report your results. Whereas right now you can try and experiment 9 ways, it works one, you just publish that one. Right. So I think that would be an issue.
And it has a content identifier every time this method has been used, every experiment is linked to it. Right. So like this goes both ways, absolutely. That's a great point. I will say that my view on this is just like build the infrastructure for a complete system that exists by itself. And then we can start implementing a lot of these like strategies and testing them. Like for example, publishing your methods before doing the actual experiment. This is a great idea. A lot of these ideas can be implemented. Yeah.
I would love to highlight just one of the other cool DeSci projects I've seen is run by Angelina Lesnikova. It's called DeSci. And she was talking about if you're running a clinical trial for a study where it doesn't get published, well, that's still valuable data that you collect in that clinical trial. Make that available to others and let them run different research on the same data that's been collected. It seems like it's a massive opportunity because I would assume a vast majority of data is never published or never made available. So your modular system it's really exciting.
I will talk to you.
Yeah, for sure.
Okay, but
Sure. Any final questions? Well, I know you said that you're not actually like super deep into the Web3 technology part of things, but what made you said you're actually building your application Web2 first, which I think is very smart, like get the product working. But what makes you really excited about the, let's say, Web3 part of it?
Decentralized funding. Like my core excitement about all of this stuff is just let's build a stable system that's like better, faster, stronger, and super powered really with the AI, right? But the only way you can do this is if you get humans to collaborate and coordinate in a way that's like seamless and optimal for everyone involved. And a lot of this I think can only be done if you have identity attached to a wallet, things like this. And if you can carry that identity with you anywhere you go, if you can keep your identity secret, like ZK proofs, for example. A lot of these new ways of establishing trust between people is really what excites me about it.
And you'd had one other comment earlier on, it was something about the community is the foundation before you can actually have collaboration.
Community structure is a precursor to collaboration.
Right.
So if we got like you and me are the same and we've got a group of sames around us and a group of difference over there, that's better than if we're all mixed together.
Interesting.
Yeah.
Yeah, it's your tribe effectively. So I would ask, have you started your own community for what you're doing at Halogen Cloud, or?
I would like to. That's a very good idea.
Yeah.
Yeah.
Well, in the meantime, I've been telling everybody here, we have our Telegram chat for DeSci SF, just for other people in the Bay Area. Blockchain for Science is my favorite Telegram chat out there for DeSci, but join the conversation and throw your ideas out there, and you're going to find so many people that are excited to collaborate with you.
That's a great idea. I'll definitely do that.
Cool. Well, thanks again, Natasha. Let's give her another round of applause.
So thanks for coming. My name is Alex. I am one of the co-founders at CharmVerse. CharmVerse is a Web3 operation platform. Think of us kind of like a Notion for Web3, with targeted specific use cases that you need for building Web3 communities, from things like managing your members, helping you set up better governance, but also have sort of the core collaboration features like creating documentation, tracking tasks, but also like turning the tasks into a bounty and so on and so forth. Really leveraging different power of combining productivities and Web3 serving particular sort of DAO or token community use cases.
Yeah, my name is Michael. Alex and I actually met in New York, and we were at like a dinner that we both sort of organized in New York City. So you guys are interested in like crypto dinners in New York, let us know. But I ran DBDAO, which is like a database that runs on top of the blockchain. And we just started talking and thought that this would be like a cool idea to sort of share with people, to say how like we thought this was like an interesting collaboration. So we wanted to sort of get people's feedback on it. Before I started DBDAO, I just finished my PhD. I was at Stanford. I was studying natural language processing and how to convert between like AI, like natural language and code. So you could do like program synthesis, then just using like what you say. I got it. Oh, you got it.
So I think we talked here from the audience, and also like from some of our colleagues and friends as well, that like there's this excitement around DeSci, around how to leverage like blockchains and token around research. We figure we'll show maybe an example or a framework to think about what's sort of the next layer of like rubbers meeting the road, like when you need to build community, what does that mean and so on.
Yeah, I mean, I think we took inspiration from like the space thing, SpaceDAO a lot. It was like, okay, we have this idea, and someone asked this question, like, okay, have you guys started a DAO, or like, how do you want to start your own DAO? And I was like, oh, we're still like thinking about how to do that and something. So this is kind of like imagine like a continuation of like, once you have the idea and once you have the funding and like, how do you start to like, what does building a community look like, and what does like collaborating on a data set look like? What does like granting different access control look like? And just sort of like brainstorming on some of those ideas. Okay, yeah. So we were looking at sort of like the current state of like what research looks like, and like especially as it relates to like clinical trials and publishing. And on one side, you have like this very like what we have now, which is like the Encyclopedia Britannica style of academic research, where it's like you collect a data set for like one thing in particular, like for clinical trials. In the most extreme case is like you have to go to the FDA, you have to get approval, you have to recruit patients, you publish in Nature. But then there's also this like other approach of doing science, which is becoming more interesting. It's like Patients Like Me websites, where it's more like grassroots, and Patients Like Me is this amazing website of people who are just sort of saying free form, looking to find community within groups and saying like, oh, like I have this rash, I'm not really sure what's happening here. When I eat broccoli, that causes inflammation, it causes not inflammation, like whatever. And it's very bottom up, which I like a lot. Of course, this like introduces a whole other set of confounding variables, which is fine, but they just have to be understood. I think, you know, a big thing we have to understand in the DeSci space just in general is understanding where the new uncertainty is in these new types of data sets, and not trying to compare them directly with existing very structured data, but sort of embracing a lot of the ambiguity that kind of exists. And I think like using AI and large language models is probably is a really great way to do that, as was mentioned in the last talk. And another other types of things, and like there's another type of side of differentiation in research is how this research gets created. So with nature, there's already like this strong ontology of research topics and acquiring funding, but then there's other things that are a bit more out there, like psychedelics or something. And an example of that is this website called Whirlwind, where it's all bottom up evaluation of different psychedelic drugs, and there's no one who's curating that data set at all. It's just very free form, but it has its own sort of new types of information. And you know what I really like about this second set of like community curated academics and clinical trials type things is it sort of like lowers the coordination costs for these other things. Like running these clinical trials is very expensive. It costs $10,000 more a patient, whereas with these other things it's kind of free. It's self-report. People have more skin in the game too when they're the patients. So in Stanford there's this big concept of like patient to patient medicine, and the thing that they noticed a lot about it was that like patients who are sick are way more interested in like figuring out what's going on than doctors who, you know, spend like 10 minutes or something before they have to run off to the next person, and they can invest a lot more time. And what we see is like a really big thing with crypto is like sort of lowering the coordination costs for patients to find each other, but also like closing the loop. So, you know, if with things like Patients Like Me or Irwin, you know, you have the data, but you haven't like tied that back that to the longer term incentive of incentivizing the people, creating IP, getting money, getting funding, and all these things. And so I think that's like one of the areas where like there's going to be like first tier value creation. So yeah, and the other things is like when you open source it, you have it makes things more accessible. People are incentivized. You have different quality metrics and different demographics, but each of these are just new factors that we think are going to be really important in like understanding these new variables in this data set. Yeah, so I think this is just a little slide that like I don't think it's almost like a new type of research. It's not like in the exact same way as existing research. Like we hope to get like emergent behavior out of this research, where it's not just trying to replicate things that are published in archive or published in existing journals. Like what we were talking about in the last talk was creating like small snippets of things that are independently verifiable, and almost like tweet style research where like, you know, each claim is much more easy to verify. And there's lowering the participation. And one of the other things that I think is going to be important is like figuring out how to do like ethical research in these types of things. Like when you're doing open research, maybe you need some sort of like IRB review system so that you don't get people doing research that might lead into a bad direction. So I think that's something that's going to have to be determined as well.
So I have a question for you.
Yeah.
So we talked about a lot of these things that happen like on chain.
Yeah.
How do you think about like gas?
Oh, I think those will go down in cost, and you know, maybe you can run a subnet on Avalanche or something, so it won't be too bad. Good question.
So with that, right? So just want to highlight before we go, like why using Web3, right? Actually, I think earlier I was chatting with you earlier on like why not just do these things like Web2 or like traditional way, you're using websites, so right? But I think given blockchains and token, you get a few superpowers. Really being able to combine incentives, being able to the people that are contributing to the project, right? In both in a potentially monetary way, or in terms of like governance, or in terms of like prestige, that is verified with EC, right? Which then you apply to like reputation, and then you can actually think about like who are the ones truly contributing, who are the ones that are helping out, and then being able to elevate those individuals. Related to that, curation. That I think DAOs particularly started off, and a lot of that today is still true, that you are voting based on token holding. But maybe that's really not the best way to go. That just because you have a voice doesn't mean the voice should be equal. I think like the more knowledge, expertise, and contribution that you bring to the table, that you'll be able to like weigh some of those in terms of your maybe reward, but also governance decision. And then finally, still bringing the fact that you could have a much better decision-making and governance process that from deciding on really anything, right? On like how your research project should be going, which biotech that you want to sell your data to. All of a sudden, a lot of this decision now can be made as a collective, and then for people who contribute. So
how have you found people building community? So Alex runs CharmVerse, which is like this notion. How is community? I think we can learn something from like how people build community and like those existing projects that you're sort of familiar with. How do you think that those could be like mapped onto like the DeSci space?
And so community building is a Web3 thing, but it's also a Web2 thing, right? So some of the tactics or like best practices really don't change too much on like finding an area that are interesting to this particular group of people. And I would say that it is more important to find sort of your 1,000 true fans and like find people who are really, really passionate about this particular topic to help, even when that particular group is much smaller, versus like instead of trying to get your first 100,000 people, find that first 100 people that really care, that can be ambassador to your project. I think that's a lot more better way to bootstrap the project and enable it to be scaled in a more organic manner.
So for like the groups that you have, do you find like, I mean, we have a Discord that has like a lot of people in it, and sometimes it feels like the discussion is like a little too big. Like, have you found that like these DAOs start in real life, or they are mapped from an existing social structure and then they come to find CharmVerse or DeSci, or how does that work?
So I would, it feels like a lot of you are creating early communities, and like my recommendation would be like, try not to model your community to some of the existing like really large DAO. I think like it's just human nature that when you have just 20,000 people or like 50,000 people like in one Discord, it's not really a community. Like community, it's very hard to care for, community member number 4,865, right? Like it's just not really how you get to know each other. So I think like we certainly try to facilitate smaller group pods or sub-DAO or whatever you call it, even though if your overarching research project require more people. But I think being able to divide and conquer and really, again, building the true community to the word, I think makes a big difference.
Cool. It maps into the thing that we talked about previously with the structure influencing the communication.
Yeah.
Cool.
Yeah. So again, super high level. How do you build the community? How do you engage them? For the particular data that you care about for your research, how do you build the incentive mechanism to collect the data that encourage the patient or participant or user to participate? Finding the right way for your community to collectively govern, make decisions. And then finally, yes, you get to the point of sharing the wealth, that having the right mechanism so it's as fair or at least transparent as possible. So again, we talked a little bit about building community. So this is some screenshot actually from CharmVerse on, one of the first things that I've seen a lot in DAOs or the token community is that all you have is a PFP and then a username that you really don't know each other at all. So like first thing I would encourage you to do is find ways to, you can use CharmVerse, you can use other things, but like find ways to, so that each member even get to know each other. From basic things like, where do you live? Or which state do you live in? Or which country do you live in? Right? Being able to like leverage each other's, or being having an opportunity to even build friendships or be able to help each other out. I think that's super important as a start. Other places to do things that, like posting content that makes sense to the community, and then enabling the members to share their experience as to build out this initial community. So give people a reason of why they should show up to your community on a daily, weekly, monthly basis. But particularly if you have been in any kind of DAOs, you see that like it's easy to go in and like particularly in the start you get excited, but then like 2 months later, it's very hard to continue that engagement versus that people moving on to a different community.
Yeah. Okay. All right. So this relates to like once communities start building data sets, this kind of relates to my experience with like DBDAO is like the first pieces of content have marginal value because one piece of data alone isn't super valuable or two pieces of data. So this is as a data set starts to be building. But then we see like the value in Web3 is as you sort of get to 1,000 or 10,000 pieces of data, the sum of the parts it's because the data begins to have more value than the sum of the parts. And so this will help to sort of lower the coordination costs of it. So if people are trying to put a lot of data into a database and people are sort of getting rewards for their data, one thing that is very important is making sure that the data is of a certain quality. So we have this idea of like a curator. So if people are part of CharmVerse or some Notion or online collective, and then they start to begin to generate data sets for results, and they're being rewarded for their data. Okay, I'm going to be rewarded for my data. What am I going to do? I'm going to try and put as much data in there as possible to try and increase my rewards. So how do we try and prevent that? Is we have this idea of like a curator, and the curator's job is to like maintain the quality of the data set. And we think that the curator doesn't have to be like one individual person, but instead the curator is kind of like a black box or like a multi-sig. So what happens is this curator is in charge of either accepting or rejecting it. And the curator this multi-sig can take the form of a DAO. It can take the form of an AI bot. It can take the form of a team who's coordinating. So like maybe we all work for a company. And if 2 of the 3 people in the company agree that this data should be removed from the data set, we can do that. And another interesting mechanic that we introduced here is this idea of putting a deposit on your data. So we want to try and prevent spamming on the data set. So what we do is we have people deposit like $1 when they post the data. And if the data is accepted, they get their $1 back. But if the data is rejected, if the data is spam or terrible content, they get slashed. And the other good thing about this curation principle is you can have multiple people curating the same data set. So you're sort of incentivizing people to compete to be the best curator. So if some curator reneges or becomes malicious, you can track that back and you can say, okay, this person's terrible. But don't worry, there's another one. And this is sort of this is like a similar concept to having like laboratories of democracy. So this is how like the United States is supposed to function, is that each state creates their own laws, and the laws that are the best will attract the best people. And similar here, by having this sort of friendly competition between curators, maybe who are curating different projects, and not having it all go through a bottleneck, you'll have data sets that could actually be higher quality. So now that we have like this is the problem we were trying to solve, is like, if people are getting something of value, the idea is like people are doing work to get data into this data set, and they're getting something of value. What are the different types of value that can be created? Basically, we sort of came up with this ontology of like people can get status. So today, people publish papers, and you get status if you're on the paper and it gets accepted into a good journal. You can also just get cash like USDC. If you're a patient participating in a program, you get paid money for your participation. But I think the things that are interesting about DeSci is the ability to potentially get equity. So if a drug is discovered based on part of your data set, you can get equity in the long-term value that that drug has. And what's interesting about DeSci also is that all of these things can be sort of blended together as well. So you can get a partial package that's set in the smart contract of the status, cash, or equity combo. So what are these things? So how do we do this is each of these different things is basically tokenized. So like a stable coin for USDC, impact certificates are another interesting one. So sometimes people, instead of status on a paper, you can get an impact certificate where it's like, oh, I participate in this thing. I get an NFT, and then I'm going to post that NFT on my profile to show that I participated in this. So for example, if you submitted a lot of data on the first that was included in the first self-driving car, people would be very happy to show that perhaps on their profile.
So then how do you engage the community? So I mean, like there's like kind of two major ways. First one is finding those ambassadors, finding those leaders. How do you do that, particularly in a Web3 native way, right? So first, it's like about expanding that access and really giving them ability to do more things. In CharmVerse, you can set it up so there's like maybe your basic contributor is a view-only access, but then your core contributor can have like write access or create access. So really empowering them, right? Making sure that like they feel that ownership, not in a token sense necessarily, but like in the day-to-day collaboration sense, like that this is their project too, right? And then related to that, being able to provide membership status. That I personally am a big fan of thinking about NFTs as membership back. It's not necessarily collectible, but simply that showing that you are part of this club that that you contribute to, that you have shown that you're helping out. Right? And then like as the community participate and contribute, finding ways and establishing processes to sort of promote and highlight these leaders, give you a chance again, like an incentive in a human sense of why would you want to contribute to this project. But then related to that is like, okay, then you can also leverage the tokens to reward behavior, right? So from basic things like using a bounty feature of either paying a DAO token or paying a combination of like DAO token plus stable coins, whatever, that just tweet about the projects, bringing people into the projects. These are things that you can natively use, particularly when used properly and knowing that people are not scamming you, be able to really sort of supercharge the growth of the project in the beginning.
So this is actually what kind of got us, Alex and I, talking initially. Is like Alex had this platform that was for basically community, and I had this platform that was for data generation. And we were saying, okay, like, wouldn't it be cool if people were rewarded based on their contributions? So we have this way, DBDAO has this way of curating high quality data sets. So what if instead of just sort of anointing leaders based on some other metrics, you anointed them based on like, how many rows did you get into the database that were successful? And then that gives you sort of governance powers on would be Alex's platform. And then you'd have this sort of like meritocracy, you'd have this sort of automated meritocracy where people who are contributing and are active in the data creation or community process would have governance rights over or higher or different community different status within the community.
Yeah, so I think like token gets really exciting, like that you can choose to reward your community based on behavior. Like you don't have to give tokens for every single little thing. Like you could choose to for like high value activities. For example, like contributing your data set, contributing your data into the core data set. But it's above and beyond that, right? And there are other activities that you can also reward, again, both reputation as well as financial. It's about being flexible, like what do you want to optimize the community for? So there's a few tools out there right now. There's a lot of tools out there right now. But some of the tools that we particularly like, we recommend you to check them out. Is that like if you are, wanting to do more like proper proposal voting, but don't want to pay any gas fee, Snapshot is a great tool that I think many use Snapshot. If you are wanting to like have a better governance when it comes to like transactions, use Gnosis. And using CharmVerse, you can also use Gnosis directly like off CharmVerse as well. And then last thing, we talked a little bit about this idea of like sub-DAO or like pods, right? Like small teams, like staying under the number of like 150 people. Metropolis used to be called
Orca.
Good at like creating pods, which are really like a community with a shared treasury, or with a shared nodes of state specifically. So easily kind of like spin up communities that you can manage with your research.
I think another thing that's interesting is each of these projects is going to have a different governance structure. So some things the PI might be more involved, or some things will be like more hands off. And the types of how the voting and governance will be done is going to be very dependent on just the nature, the dynamics of the research. Okay, so say we have all this data and IP that's in the database and how we want to distribute the rewards. These are just like, that would be set. This is an example of how this is a concept we borrow from DBDAO is like, okay, we have this data set and it begins to monetize. How do you split the rewards? So you could split it 10% by the PI, 60% by the researchers, 20% by the subjects as an example, but this would be split. And I think it's also interesting to think about how we reward people who contribute data. So there's many different ways of doing it. One is to just like the database gets $100 in value and there's 100 rows, each person gets $1. Perhaps it's done by a query though. So instead of giving it equally, what if one person's data has been touched a lot more and you just measure that based on a per query basis? You can do it that way as well. And then lastly, there's this concept of a Shapley value. So some data just might provide more incremental information to a data set. So if every color in a data set is blue and then someone inputs a red color, the amount of new information that is provided by this red color is much more valuable. So you can also pay people based on sort of the dynamics of the individual pieces of data that they contribute to the database. And these are just different ways of sort of paying out different amounts to based on the different quality of data that's out there.
Yeah, so again, really want to say, I think super early when it comes to DeSci, so we just hope that we will encourage you a little bit about, there's a bunch of tools out there today that you can use right now in building your community by following hopefully this like slightly lightweight, 5-step framework to start to build, engage the community, get your research going, and like really actually making DeSci real. And yeah, remember some of these so Web3 superpower. It's about enabling transparency. It's about aligning incentive based on tokens and reputation that you can provide. And then like really sharing that ownership at the end of the day. I think like that's what makes it super fun and exciting.
Sweet. Thank you.
Any questions for the gang at CharmVerse and DBDAO? Maybe if we jump back to your 5-step. Oh, great. Yeah.
Thanks. As someone who has, dug through a lot of health records, contributing to databases, it's not always easy, and it does take a long time. And traditionally, the acknowledgement for such work typically gets passed on to the PI. So I think really what you're doing is really cool and emphasizing the contributors and letting them benefit from it, not just from publications, but actually financially. One thing that I question is, this does not incorporate healthcare data, though, right? This would be kind of more consumer data. Is that correct?
I think initially it's for public data, similar to Baechle was talking about. with DBDAO, we can do encryption on certain parts of it. So it depends. It probably wouldn't touch HIPAA though, because that's hard to do on chain for a variety of reasons. But we could, additionally for like self-report stuff, I don't think that needs to go through HIPAA. So it depends on more specifically on the use case.
Yeah, that makes sense. That's a good distinction. And then the other question, I guess, would be, this should be really good use for characterizing benchmark data. To compare something to, because most trials and most experiments now have to basically run a control, whereas the control should basically already be characterized, right?
Yeah.
No intervention should already be known, and this would be a really good tool for that. So you really just run a treatment group and compare it to a very, very, very large powered control group.
Yeah, like establishing a baseline.
Yeah, baseline.
Yeah.
Actual decline in certain functions.
Yeah, I didn't even think about that, but that's a great, just like baseline use case of it is to just collect large scale data on some benign thing and seeing like what is the average temperature of people, so you can detect if there's an infection very easily or something.
The seemingly uninteresting aspects are often not well reported, and then you have to go out and design an experiment to measure something that should already be characterized.
Yeah, I like that. I mean, getting back to your thing around like the credit going to the PI, one of the things we chatted about was like having different things, like giving credit specifically. So right now on existing papers, the attribution is sort of in rank order, which doesn't, and then confusingly, like the most important person is typically at the end. And, an NFT could include something of like the specific contribution. Was this person responsible for the idea? Was this person responsible for doing the data visualization? And getting very clear attribution for different parts of the experimental process or contributing data or anything like that.
The lowest ranked person, the person with the least amount of degrees on the paper, probably didn't do the paper.
Yeah. And I like that idea about the baseline. Actually, that's very good to know.
Super exciting. I hope we can collaborate with Weavechain, because your shared ownership of wealth bits, we're getting really excited.
Oh,
I've
yes.
never thought about that, like, valuing higher the unique data points in a set or the most used data. It's really fascinating stuff.
And I guess it's less of a question and more of a comment and follow up on everything else everyone's been saying. But it seems like almost even a way to the way that individuals are able to own their own data and look through monetize their own data, sort of generate have this concept of like a UBI just based upon your own personal data. It seems to be maybe a way for communities to sort of do that, to generate intrinsic value at the community level.
Yeah.
Maybe you could, it's less of a question, if you have any comments or thoughts on that.
Yeah, I'll take the first one, then I'll hand the mic. But so basically, like we were proposing and implement this on DBDAO, and on DBDAO, every piece of data is an NFT that you have ownership of, and that equity flows to you based on the usage of your NFT. So yeah, so as you contribute more, you are the owner of that NFT where the data flows to you. And yeah, you can definitely monetize it as well. So what's also interesting is because it's an NFT, say you're making $1 per month based on your data usage in something. Then you can I can sell that to Alex based on 10x the yearly revenue. So I can sell it to him for $120. And then he's now the owner of the future cash flow in that. So you can sort of also, because it's all tokens, you can definitely use it to create like a stream of UBI. Yeah, that's probably the future might be the future. And then
Sorry, can you repeat the second question? Or yeah. So I think for me it's because not every piece of data has the same value. Right. So I think like being able to start to think about like what are the ones that you would want to spend in assigning NFT to, so that like that actually have you think with future value minus the gas fee. I think that will help really drive that truly value exchange of like data versus like now we're just thinking about always like, well, you gave all your data to Facebook, but that data probably doesn't worth a lot to you, honestly. Right.
So I heard is that your individual user is worth maybe $7 a year on Facebook.
Right.
It's really low.
So the turning everything into NFT piece, I think is really interesting. We were saying about if the value of the NFT increases, we sell it and someone can use that and earn money. What happens though when the value decreases, then people will just sit on the NFTs, and then your entire database is filled with people that are down right now and they don't do anything. Then you just have a dead database at that point.
Well, the data of the value of the NFT is backed by the IP that's inside that NFT. So how that data is, I mean, the price of a Bored Ape is based on what other people are willing to pay for it. And so I think like IP that's embedded, that's encapsulated within an NFT is probably much more stable than the fluctuations in Bored Apes. So yes, they could go down. I mean, the value of a patent that is no longer useful is worth less, and but it's still a database full of less valued IP. So I think, I mean, it will be worth less, but I don't think that's too big of an issue.
Maybe I could follow up on that one. Any chance you could go back to your original slide where you're talking about the patients being more interested in the outcomes than the doctors? I think it was, yeah, the current state one over here. Because Bill, we were chatting about this earlier, right? Where you're focused on rare diseases, correct? And, in that case, like maybe there's not going to be a great study that's done for it because there's not so much commercial value after the fact, but the patients really, really care about that. Bill, would you want to say a few words on your perspective on it?
I don't know how to chat. I'm happy to go ahead and say a few words. I don't know how to solve the problem. I mean, it turns out the real issue that comes up is if you have a rare terminal disease, rare sucks because there's not a big market for it. And terminal sucks because you don't have a lot of time to solve the problem. So when you go, and so motivation is tough to go on and get all the people inside this and even to go on and contribute. And then at the point that they go on and put the data in, incentives suck because they don't really, people that are dying don't really care about getting money for usage of their data. They want to stay alive. So the incentives are kind of skewed a bit in this kind of a model. We
were having a discussion at lunch, actually. I mean, there's multiple incentives in, I think like that's one of the, there is of course money. So when an investor invests in your company with cash, they expect cash back, but I don't think that's the only method of thing. I mean, as Bill just said, like, time is the most important thing. So if there's other ways of creating time for people, that is an insanely valuable thing that could potentially be unlocked with crypto. I don't know.
The one thing you can give people, which I do care about, is purpose. Okay, so if it turns out, in fact, you've gone over and have made a contribution that matters, especially near the end of your life, to go on and defeat a foe that's ultimately defeated you, people buy into that a lot of times. So, but still, it's a tough audience to sell to. And it's a yeah,
that's a good point, Alex.
No, I don't think Web3 is a silver bullet to all these things, right? But I think like one thing for that particular case I can imagine is that one of the more difficult thing is distribution, right? Or just finding it's just not worth it, or financially difficult to find all the patients that have that particular condition. So I think like being able to leverage tokens or other means, reputation to encourage to bring people into the community, hopefully that will amplify the number of people that you can bring into the study and so on and so forth.
I'll add one more anecdote and then pass it up. My dad had a liver transplant 30 years ago before the space was far along. I remember, he was able to survive longer than anybody thought, but he was basically practicing science on himself. He was treating himself like an experiment and literally like measuring the grams of lima beans that he was going to eat at meals and things like that. And all the data from his self-study is nowhere, right? Nobody can actually benefit from that because there was no mechanism for him to share with anybody else.
Yeah.
And again, he was interested in saving his own life at the time, and he was super motivated. And maybe if we can make these tools available and find those communities of people that are like them, that they can share it and make it available for the future.
Yeah.
I have one comment. The supplements crowd. Okay, it turns out there's an incredible market out there for supplements. People are going on and taking this, that, and the other to go on and change their blood biomarkers to this, that, and the other. It's not recorded anywhere. Okay, so having a self-reporting mechanism in fact might be a great way to go on and do this, starting with supplements. So.
I mean, that gets into the baseline that you were talking about earlier. It's like having a baseline for supplements like vitamin C or D, or these things that have been tested over and over again with marginal success. And if there's a strong baseline, maybe a large enough N, that would work.
Any other questions or comments for Michael and Alex? Getting any other bits of your histories, backgrounds, Web 2, Web 3, anything that you guys sort of led you to this moment?
I am an engineer by background, been started coding as a developer for a defense contractor where you put software on defense drones. Although for the past 12 years, I've been building startups. CharmVerse is my first Web3 startup. Before that, I started 2 AI company, both VC-backed, exit, and so on. But yeah, super excited. When I started to interact with DAOs and other token communities, and kind of really seeing this possibility of letting people to truly interact and work across the world, and then truly being measured by your impact and really sharing that ownership that really have nothing like it before. So I think that's super exciting for me.
Before I was at Stanford doing a PhD, and before that I was an undergrad there in computer science. And then I thought just Web3 was cool from a technical perspective, and it seemed interesting. And then we sort of looked around, and I saw this use case which could be interesting as well, to enable new styles of web applications to be developed that gave partial equity into the people that were contributing the data to them. And then we sort of got connected around DeSci and became here.
Michael, are you part of the Stanford blockchain community?
I was, yes. Then I graduated, but I guess still. So I'm an alumni member.
They had that Science of Blockchain conference.
Yes.
It was really good.
Yes.
I was having them on slides earlier because they have a really strong program. That's exciting.
Yeah. I was there as well.
Cool. And Alex, maybe you could just comment a little bit on what it's like being an entrepreneur in sort of different fields, and how you're seeing, Web3 as separate from the AI world.
Yeah, I mean, so at least particularly for my journey had always been like, there is a technology shift, and again, from my past 2 companies that were more in AI, and then like applying that new technology to solving a set of real problems. And that's certainly what I get excited about Web3 and Web3 now, right? Because I feel like blockchain or token, whatever, 5-8 years ago is a lot more speculative and just purely trading. I am super excited about the idea of building this worldwide computer, right? And then that's really not possible until somewhat recently.
How about from just general fundraising climate, running a company, experiencing the crypto winter now and all that stuff? Any parallels to things that you've seen in the past, or
yeah?
I
mean, first of all, I think we're both pretty lucky that we raised our money before the crypto winter. So in a way, it's awesome. But I mean, I do think that it is a better time. I mean, everybody said it's a good time to build, but I think it really is true, because like when everything is just something that you buy the token and then it goes up, it's very hard to tell like what is the true, talk about like product market fit, right? Like, are you really getting product market fit that by solving a problem, or you are just getting a lot of excitement because people want to buy your tokens, right? So I think like being in this time, at least right now, I think give you a better chance of like figuring out, are you solving a real problem, and believing that like if Web3 is real, then the next bull market will come, and then you're just better set up, having the right product, solving the right problem. And now is everybody's again super excited about it.
Oh, what was the question? Fundraising. I mean, I was a PhD student, so being a PhD student before is very different from running a company. You have different deadlines. It's actually, I think it's just a different set of challenges. I don't think one is better or worse. One is more academic, but also coming from PhD land, I know all the I feel like I know a lot of the problems that exist within decentralized science, and the different types of incentives that are out there. So I think it's like there's a low baseline in terms of reproducibility and different ways. I think one of the things, I don't think it's better or worse. I think we're going to create a different type of science, honestly, where it's it's solving different problems for different use cases. It's like sort of comparing like a truck and a car. Like they both travel forward, but they really have different use cases. I don't think we're probably going to use DeSci to solve like insanely complicated things where you need a lot of domain expertise, potentially. But maybe it's better for like broader Wikipedia style things. But I could be wrong on that, so we'll see.
Let's go, right? Let's give one more round of applause for our speakers. Great.
Hello, everyone. Hello. Well, this will be quite the interactive session, ideally. I mean, it depends on you. I'm definitely going to ask you a bunch of questions. So if you want to move closer, you're welcome to. But otherwise, I also welcome you to scream down loudly from wherever you're sitting. It's a long slot, and I will definitely not spend all of that talking. In fact, I think what's interesting about DeSci and generally about doing things in a more decentralized way is that ideally you collaborate much more. So I won't be talking at you for very much. And generally in these things, the algorithm, or like, I guess the mechanism really to some extent is, if you want me to stop talking, you can just start talking. So it's going to be very, very collaborative and interactive. And I really mean it. So whenever you have a question, when something's not clear, just shout it out. Let's have a discussion. It's early days in DeSci, and you're all here for a reason. Probably most of you could be on stage. So let's make this collaborative. Okay, so what I'm going to talk about today, sorry, I should say I'm Allison. I'm the CEO of Foresight Institute, a nonprofit that was founded 30 plus years ago, almost 38 at this point, by Eric Drexler on the books Engines of Creation, which was a long-term promise of molecular nanotechnology, like atomically precise manufacturing. What would it mean if we could actually build things with atomic precision? And it also had a bunch of other technology interests. I came to the organization 10 years ago. And so since then, we've really kind of like taken on many of these tracks that were previously, I guess, like more like researchy. And you've seen like many of them already spin out into really like their own research fields. But in a nutshell, what we focus on is molecular machines, which is this idea of molecular manufacturing. What would it mean if you could really manufacture with increasing precision, neurotechnology, and here the goal is really brain-computer interfaces, and like ideally at the end of the day, whole brain emulations. What would it look like if we can actually do that? Longevity biotech, which I think is now really just like since a few years at least has become a little bit more of a no-brainer. And so basically the idea that, what could it mean if we hit escape velocity in longevity? How can we get there fast? I know that Jordan already spoke about the intersection between space and longevity. Actually, space pretty important. So here we focus more on the near-term stuff like asteroid mining, but then also a few of the more further out things that aren't really being taken into account very much. Like one of our fellows is working on like how to mine a black hole, and so it gets a little bit more further out there. But the intelligent cooperation one is the one I think that is most familiar to you guys. That is basically our phrasing for saying what would it look like to in a decentralized way collaborate intelligently with other humans and ultimately other intelligences. And I'll get there in a second. But what does it mean that we support these areas? Well, we have a bunch of different ways in which we do that. So we do research ourselves, but really what we do is we host seminars in all of these areas. So if you're interested, once a month we have a keynote seminar. This is always a small group of people working in this area and working in the space. We invite them, like it's about 200 people in a Google group, and they can like do like a gradual of like review of like what's happening currently in that space. And we then publish that as YouTube video, if it's on the record. Those are like, I guess you can call them classes, really. And so if you work in any of these areas and want to join them from the inside, there's an application form. Welcome you to do so. They're good fun. We also do workshops in these areas. So in all of these, we have a workshop going on once a year. We give out prizes and fellowships. We've given the Feynman Prize now since 1993. And we have fellowships as well. We just closed the one for this year, but the one for next year is open. And so if like you're interested in being like, I guess having a few more senior folks in your area, or like investors, philanthropists, and so forth, mentor you in your endeavors, then I welcome you to check that out. But like, that's just to kind of tell you, but like, what does it mean that we support these ecosystems? In a nutshell, like we support these like very early stage technologies that are still a bit too out there or too ambitious for legacy funders to support. And we try to like kindle an ecosystem where there really isn't one yet. And that's done through these seminars, prizes, fellowships, and so forth. And so why am I telling you all of this if we're talking about DeSci here? Because we came kind of from the DeSci space as a more normal traditional science organization. And so our main project here is tech trees. And so me running these programs, I often get the question of like, well, I'm an investor. I would love to invest in like rejuvenation companies. What should I invest in? Or like, I'm, I just finished grad school. I don't really know where I want to go and what I should do with the rest of my career. And honestly, I'm really not, I really shouldn't be the person giving any advice on this. And so after a while, we thought, okay, what if we build these technology trees? And so what would it mean if instead of like having to individually guide people into different domains, we can actually map out what it means for a space to exist? And so, for example, for neurotechnology, what would it mean to go from here to actually brain-computer interfaces? And along the path, what are the different technological milestones that we have to hit? But also crucially, who are the main actors already on there? So let's say you want to work in a lab, and you want to work in a specific piece on brain-computer interfaces. You know exactly which labs are out there, what work they're doing, and you can kind of like self-select a little bit faster into areas that are perhaps undervalued. Also for investors, it's interesting because you see like the space, the main actors in the space, and how to best plug in. And so we set out to do that last year. And so that's what I want to talk to you a little bit about. And that's where I really want your guys' input. So we have this team of like our pioneer team. So for molecular machines, we have one postdoctoral fellow at the Northwestern University from Iryna. She's at Max Planck. Ying-Tong Lei, she's at the Electric Coring Company from space. He's at the European Space Agency. And then we have Foresight's research director, and they went out and did like a scaffold of like, how does that field look like? Who's working on what? Where are currently undervalued areas? And so maybe I would love to have a hand up. So we have the areas longevity biotech, intelligent corporation space, molecular machines, and neurotech. So maybe we go like one by one. Is anyone here working in longevity biotech? Hands up. Okay, I see one hand over there. Okay. Huh? Yeah, that works. That's working. You're doing your job. You're pushing the field forward. Cool. So maybe we just dive into that tree. First, I think the other ones are still a little bit like even more esoteric. So in a nutshell, basically, they're already on the website. They're still under development. We started them this year, but we built the software in-house because there isn't really one if you want to outsource it eventually. But you can kind of see like the gist of this. So at the end of the thing, you have different goals that we may want. And we call longevity biotech like in a pretty, I guess, more of a out there ambitious term of like it includes body replacement, body enhancement. So it's more like a transhumanist vision of longevity. But then also more mainstream areas like, really just reducing rate of damage accumulation, increasing rate of body repair, and so forth. And so in each of these areas, we basically try to see, what are the main kind of like components that we need to solve along the way, and who is working on which parts of this. And so if you click or like zoom in on any of these nodes, they all stand in relation to each other, but what you see is kind of like roughly what is this concept about. You see like a little pop-up that tells you what this is, why it's important, and then you get like labs working on this, companies, and if you click on them, you get directly to the website. So if you're interested in working at these companies or labs, you have like a bit of an easier digestible shortcut to them than just literally like reading a bunch of reports. And so one other thing that we really want is challenges in a field. So what we did basically by coming up with them, because on the one hand, it's nice to know who's already doing what, but on the other hand, it would also be really good to know what do these people actually, what's holding them back, right? Why are they not progressing faster? And so the second question that we ask people, apart from like, who are the actors in your particular space, is like, what's an undervalued challenge that you really wish you could solve if only you had the time and resources? And frankly, you come up with a bunch of different challenges there. People really have like a long laundry list. So for those of you who are working on longevity biotech, which is one person, I'm putting you on the spot now. What are you working on in longevity biotech in particular? Okay, cool. So what is one thing where you're just like, if only I could wave a magic wand or I had a postdoc working on this or whatnot, what would you love to see solved? What would like bring your field further along much faster? Well, I have 40 minutes for the slot, so if you want to monopolize it, go for it.
No, the question is not if I have limited time of research, not the limit. No, I want to.
You have a genie.
Okay, so well, I think the key problem of longevity field is the lack of paradigm, because you know we all age, but nobody understands what for. That's we are working on.
Mm-hmm.
So there are many observations that you see in your slides, but what of these are primary, what are secondary is a question.
Yeah.
So like you have a flattened tire, you see a flattened tire, do we need to pump it or we need to look for a notch or a nail in the... So these questions are still not answered in longevity research, and I think that's the key issue.
Yeah, well, you're asking the meta question here. Like,
yes.
How do all of these individual bits relate to each other, and what do you do about them? Like, you know, do you
if you
like,
want to like
do you repair, do you replace, do you,
if you want to me to share an experiment that I will never do because I don't have time and money. So there are, you know, there are these snake mole rats.
Yes.
But there are also furry mole rats. That furry mole rats, they also have eusocial structure. They have queens and workers. And it's easy to transit from the worker to a queen. And the queen is long-lived and the worker is short-lived. So it should be a very simple hormonal regulation that should make an animal long-lived. And I if I would be infinite life, infinite money, I would study that probably.
Okay,
because
great.
it's fun.
So look, this is really concrete. You're even giving us like experiments here that we could do. So this is exactly the question that we ask people in the field of just like, if you had this one thing, you know, like, what do you think there isn't like, you know, enough resources spent on? And then what we do is first we go out and put bounties on it. So we had like a bunch of Gitcoin bounties on individual things. Here you see a few on dietary control, autophagy, advanced glycation end products, and people basically produce like quick one-pagers or something of like, this is what I would do. And then they get 500 bucks for that. I guess it was an ETH, so I don't know what that is right now. And it used to be 500 USD at the time. But, you know, in a nutshell, we're really trying to like already get into the point of like problem solving and like outsourcing and decentralizing this kind of whole process of like, how do you make progress on a field? And the idea is that over time, well, I'll get to that in a second, but I'll show you what we want to do. Obviously, it shouldn't stay with the bounty. What you can do is, you know, like you can have IPNFTs. Later on, you can actually have like entire funds, like Syndicate DAO sitting on a node and like funding bits. But I'll get to that in a second. Let's like maybe figure out another one. Is anyone here working in space? Okay, Jordan's out there socializing. Too bad, Jordan. I can't. Okay, he's here. Jordan, you're working in space. So great that you're here. I'll put you on the spot right away. So I know. Aren't you glad you could just came in here? So this is like roughly like Romain kind of like clustered the space of like the space of space technologies, and had like, you know, a few like individual bits of like, what does it actually look like to make progress in space? So we have everything here from like from power to propulsion and space. Like, I mean, the interesting thing about these sectors is like they're really, each field requires a very different crystallization, but we have the remitigation, in situ resource utilization, and so forth. And so Jordan, what part in space are you working on? For those of you that don't remember from last one.
Longevity.
Space longevity, great. Yeah, the intersection. Wonderful. If there was one challenge that you really, really, really want to see solved, let's think more with the space head on. What would that be?
Inflammation in space.
Inflammation in space. So see, we actually need to create a new node here for actually the space longevity overlap. And so I should also say, I didn't say that at the beginning, one really big draw for us of creating these tech trees is that over time, different researchers in one field can see how their fields overlap with other fields as well. And so over time, you get this interdisciplinarity really well, I think, together, and people can just like place themselves in relation to other people too. Okay, maybe let's do one where more people here in the space are working on. Thank you, Jordan. We definitely need to get a longevity note on the space tree. So this one here is on basically decentralized computing. And so we have everything from decentralized data governance to decentralized consensus system, private computation, private artificial intelligence, private decentralized computation, and long-term AI problems. Is there anyone here that, you know, where you think that you're working on the space of decentralized computing? Decentralized computing. What would be the number one thing that, first of all, what field, like particularly where you work on, what subfield there, and like what would you like to solve if only you could?
We go and give Web3 properties to databases. So making it so that you can have a Web3 secure lineage. So data hasn't been tampered with. We know how it's been accessed. And then making it available for things like confidential computing.
Wonderful. Confidential computing. Here we are. Well, we have private and private decentralized computing. And so I think that there's like a lot of things really that, you know, relay at that intersection. What would you like to solve if you could wave a magic wand?
I had a few interesting conversations today with people that were saying that, you know, even if you have confidential computing to go and be able to analyze a data set, that people could actually extract data from the results and recreate parts of the data set. So I wish there was one magical blended confidential computing algorithm that would be ensured to not exfiltrate data, but just make things work as expected.
It's centralized computing. Great. Well, actually, I think with federated learning, it could potentially,
it's close.
It could work.
Mm-hmm.
Okay, cool. So, you know, again, as an example, we would have that challenge and we'd put it on the map, right? And so the idea here really is that we're adding a bunch of actors that are working on individual fields. We're adding a bunch of challenges and then put bounties on them to solve them. So that's the current state of these trees. I'll welcome you to check them out. They're all online here. If you're more into neurotech, go for it. This one is getting into crazy realms of like really long-term molecular manufacturing. So like, I think for everyone, you know, whoever is working on something, there's really something there. I just talked with someone yesterday who saw me present on this at ETH Amsterdam. And based on that, she started a whole molecular, like a design tool framework for molecular machines and is now using that to make more long-term progress. So I think that like the main goal here really is like to more quickly get people into where they should be within the technology sector. Okay, cool. So that's like where these trees are now. I already told you that on the long run, we really want to put more bounties and like put more money on actually individual problems by like interviewing more domain experts. But then if we think really long term, or like let's think medium term, ideally what you want is also prediction markets on that, or something like impact certificates, so you can actually track which of the different things that you fund make the most progress. And we have like one work stream working on this too. But like if we go like really out there all the way, what could these tech trees look like? What we could do with them on the long term? Well, glad you asked. So there's one, let's start with the medium term one. So Balaji, Trent McConney from Ocean, and Evan from Protocol Labs, and a few others, and I have we collaborated on a hackathon earlier last year to make a better tool for in a decentralized way, actually like crowdsourcing and crowdfunding these tech trees. And so we had like a hackathon for about like, I don't know, I think it was 3 months or so, with the top prize. And that's because we all came to this idea of tech trees from a different way. We just wanted to map our spaces and help people get in. Balaji, like a little later, published this post, like it was a tweet at the time, of a tech tree that looks a bit different. So this one is a tech tree where you don't map out like an area, for example, brain-computer interfaces, but here an individual investor has a tech tree, and they are basically like have this kind of like hypothesis and like, you know, this thesis statement, and then they slot different technology stacks that they find along their way and add them into their own tech tree map. And then, you know, you can imagine different people coming in and mix and matching, like, you know, like if I'm in another angel, I'll see Balaji's tree, I like maybe grab a part that I find great and like leave another one out that I don't agree with. And over time, you have this kind of composability of what individual angels are working on. And so you could already see, okay, like there's a bunch of people over here clustered in this particular longevity side. I'm going to go over here. And so that was another really, I think, neat way in which these tech trees can be used. And then the very far out one is from Trent McConney. I really, really welcome you to check out the post that he wrote. It's called Starships and Tokens. And he takes this whole thing up a notch. So now imagine you just saw me presenting on individual tech trees for an area like molecular machines, brain-computer interfaces. So Trent basically slots them all together. So here you have clean drinking water and reduce poverty. Like, what would it mean to solve that part? Great. Here you then have like, you know, kind of like safe AI that actually helps humans. You have like, okay, AI takes all the jobs, and then, you know, what do we do about this? So that's like one front here. And so that's the intelligent cooperation part that I showed you also in ours. Then here you have the brain-computer interface part that I showed you in our in our tech tree. And so he is also thinking about, okay, how could the brain-computer interface part work? Here he has the space tech tree, like definitely important if you want to reshape the cosmos. And so that's like another kind of individual tree that we're building. And then up there you have the share computer one, which is more like the intelligent cooperation tree that we're building. And so he basically came from the other direction and already slotted all of these pieces together and had this ultimate tech tree of what it would look like to kind of build on individual areas and like actually reshape the cosmos in the long run. And I know that sounds like a lot, but now just imagine really if we had individual challenges like on these nodes roughly, and people could, you know, like, I mean, for him, he basically just said it should be QR codes and people can like basically just donate to them. But you could also imagine, you know, like them being IP NFTs. So everyone who like funds a specific node, on the other hand, you can get project proposals for solving it. And then everyone who funded a node gets a fraction IP NFTs for like having contributed to it. And so over time, you can really track research. And now one step further, what would it mean if people could not only propose with research proposals, but could actually pitch at early stage companies? So for example, I create a syndicate DAO that really only focuses on this one part of like Dropbox your brain. I say basically, I want to only fund companies that Dropbox your brain. I create a syndicate DAO, slot my money in there, have it shown on the tech tree. And on the other hand, founders can propose with their companies. Then there's a kind of like review mechanism that could either be done through like a multi-sig, what have you, or like a more elaborate process. And then eventually you can fund a few projects, and then you can track with the prediction market really like along the entire area how fast you're making progress toward the long-term goal of exploring the cosmos. And the cool thing is, you know, like you really pick up steam if you like know who's working on what, and roughly where you want to go. I think you can really coordinate people to do outrageous things, because no individual would right now be like, okay, I'm going to fund everything that's over here because I know everyone else has got this covered. But if you could make that a little bit more transparent, that different people take on different chunks, you could actually go quite fast. So it's like it's a little bit more a collaborative approach to like long-term civilization scale progress in a decentralized way, I think, you know, crucially. Okay, so that's one. Are there any questions, tech tree specific questions? Okay, I have a few. Yes.
Thanks, I can hit it right back. I was wondering if you, so I guess best way to phrase this question is, do you think the bounties provide an adequate incentive for scientists to pursue them? Because just coming from the science field, a lot of scientists pursue their passion. So even if it isn't in line with the tree, you know, it might be out here, but they're like, this is something that I really want to solve for personal reasons. Do you think that there's a way to align those incentives? Or do you think the bounty suffices that?
Yeah, I don't think bounties do really very much. Just we're pretty funding constraints. So like the best way we could do is like, okay, at least like send us a one page of how could you do this? And so, you know, ideally, I mean, it's great if people are already self-motivated, in which case, you know, like if they're working on something that actually has like an impact for like long-term technological progress, all we would need to do is just slot them, like basically map them. You know, we could just list their work and other people can then fund them. Like, you know, currently we're only listing labs and companies, but you can also list independent researchers eventually. And like, for example, if they have a funding request, and you know their individual pet project happens to be at a crucial node for long-term progress, if you list them on a tech tree, other folks can like have that visibility and just be like, oh, I didn't know that someone's actually like already got that. Okay, fine. Maybe I'll up the funding. And so I definitely think that if people are self-motivated, even the better. We definitely don't want to discourage that. But some people may not be, or some people may also just not know really like what to focus on. Any other questions, comments? Red teaming, criticism.
Yeah, have you thought about linking your like sort of high level tech trees with more of the details for the specific studies? I was chatting with about Singularity.ai, and Natasha gave an interesting chat later where they were trying to go and break down within a paper what are the concepts, almost as metadata for the paper that could maybe, bubble up through your high level graph?
Oh God, yeah. Natasha, actually, we had this workshop, crypto security and AI workshop recently, and Natasha came up, I think, with that project at that workshop. That was a few weeks ago, and that was because, I mean, we had a short tech tree run there as well, but we also had Martin here from Discourse Graphs, who maybe a few of you know. Anyway, there's a bunch of like interesting mapping tools out there right now, and obviously, ideally, you want to link out to as much as you possibly could. And her project is definitely one that we're hoping to interoperate with eventually, if we get there. So I think it's a good time. Like more and more people are currently building these tools, and I think they ultimately, the more composable and interoperable they are, the better. Yes, absolutely. I think it's a great idea.
And then just one quick follow up to that: is the data set that you collected, do you make it open?
That is a great question. So currently, the way that, I mean, currently, if you click on a tree, you see it as viewer mode. But what we're doing at the end of this year is, hopefully, if we're on track, to outsource it so that you're in edit mode. And so different people can leave their comments. So basically, whenever you click on any individual node here, right, you see a little beacon, a little pop-up come up here. And so this pop-up then looks different. It looks like a comment box. And you can basically just like edit a node and then hit submit. And then people on the back end see that. And so basically, I think here you still have to go and actually save it and send it. But like ideally, not ideally, but like we're actively working on like actually being able to submit this. And so once you've done that, then in the back end, folks can review the node and can, if they like the change, can just can immediately accept that. And so we're trying to basically get from where we are right now into a more decentralized structure. At the same time, I'm working with Trent from Ocean and with a few others on like actually creating a decentralized data storage that sits on the back end. And so that's kind of happening in parallel. We're building out the front end still in this format, and then eventually, hopefully, we can snap them together. And so this can live on a decentralized infrastructure for crowdsourcing as well.
I'm going to follow up with you on that. I'm going to join that conversation.
Yeah, please do. We have a lot of work to do there. It's kind of complicated. Yeah.
So I assume all this, the thing that tweeted is just a screenshot from Civilization. I don't know if anybody's played Civilization before.
That is what these trees are based on. Yes,
exactly.
In case you couldn't tell.
What I used to love to do in Civilization was a really narrow focus on, I just want to get as quickly as possible to finding out gunpowder. Or
hopefully not this one.
Yeah, maybe not. But similarly, I have some very narrow interests, like my knees are shot and I want cartilage regeneration and neurotechnology. I think it just seems like there's so many out there pieces of the tech tree that it feels a bit overwhelming. Is there some sort of a bound where you can be like, if you donate $1 million, this will be ready in a year? Or is it just like, like curing cancer?
Okay, so
or is it,
no, you bring up a great point. So I think for the longevity one, because we actually know what that looks like. For example, we just started together with DeSci that was funded through like a quadratic funding round. They basically got funding from Vitalik and a few others that was then matched to start a longevity prize. And so currently we have a longevity prize out there that kind of is almost like, you could think it as the bounties being like individual pieces to, incentivize a little bit of research. And then the big one, it's called the longevity prize. People can already propose projects to that. That sits at the end of this, basically. And one that was proposed actually by David Furman was basically rejuvenating a human 5 years younger, basically. And that should be a massive one, right? And that could really be slotted almost like as a meta prize at the end here. So you can definitely do the high end goals too, of just like, hey, I want to do the big prize at the end of basically fund the end of the pot rather than like the individual steps to that. If you have the money, go for it. Please let me know.
Not anymore, maybe like a year and a half ago.
Fine. I will slot.
Bitcoin's not doing too well.
Well, if it goes up again, let me know. I will happily slot you here and make a little roll for that. Okay, any other question? Otherwise, I'll go to the second part of the talk. Also very interactive, maybe even more so than the first one. Okay, cool. So if you're interested in tech trees, if you work in an area in this field, if you want to collaborate on this, if you want to get your own labs listed, if you want you're an independent researcher, you want to get your research listed. If you want to fund bounties, we have a whole backlog of them. I think about 50 right now that we'd like to fund. There's a bunch, basically there's a bunch of ways to collaborate. If it's by building, by adding your stuff on the content side or whatnot, just let me know. My Twitter DMs are open. Now let's switch gear to the second part, which is on gaming the future. So one thing that I think also is clear to many of us here talking about DeSci is that this tree is a little bit different than the others, because crypto is not only like a technology sector, but it is actually one that has the potential to fundamentally reshape how we do all the other technology sectors, right? That's why we have DeSci here. How do we use crypto, which could be one technology cluster, to actually reshape the whole of how science work? Before that, we had the same for finance. Now, what I'm asking in the second part of the talk is to think that a bit further of like, if we actually take this concept of like DX seriously, what does it look like to DX the entirety of the way that like human civilization cooperates? And so we kind of like went through this thought process and we came up and wrote a book called Gaming the Future. And so that book is now available for pre-order, and we basically answer three main questions. The first one is, how can crypto help humans cooperate better? So in that, and we'll get into that in a second, but you have everything from like quadratic funding to whatnot. Second one is, how can crypto, like cryptocurrencies, but also crucially the underlying cryptography, help humans defend themselves against all the technological risks that we will eventually be encountering. We won't only be building the good stuff, we'll also be building the gunpowder stuff. And then the third one is, how can crypto, the underlying framework, help humans and AI cooperate? And so, you know, the main kind of like Peter Thiel's, like, you know, I think it was him who said that, like, you know, AI is authoritarian, crypto is libertarian. So I actually think that there's a lot of like interesting opportunities to, you know, for crypto to shape the way that AI operates on the long run, and to actually make it more accountable, make it more decentralized, make it more democratized, and so forth. And so we basically went out and kind of like wrote that book. Mark Miller, who was one of the co-authors, he was an early cypherpunk. And, you know, he had always had this long-term vision of agoric markets, basically like, you know, what would it look like if individual entities, whether they're computers, humans, what have you, cooperate in an open marketplace in a decentralized way? And he wrote these papers 30 something years ago, the agoric open system papers, and they're still like a total classic. And so basically I sat him down in interviews for a year and just extracted all of that and tried to bring it together with the technologies that are now coming online. And so that book is available, but it also exists for free as a Substack book. And so we didn't only write that with the three of us, or like me, him, and Christine in a corner, but we basically wrote it with the Intelligent Cooperation group together. So this entire group, the seminar group that you see here, is part of the group that like collaborated on the book as well. And so we had all of these, because for us, like the reason to write a book was we want to actually have progress occur much faster. And so we invited a few of the top thinkers that we know in crypto, and like basically just asked them, like, what is it really that you're currently working on? Why is this important? And like, what is the long-term potential for this? And basically through that, we weave those in the book. Eduardo, do you spot yourself here? And weave that into a book, which is also a Substack book. And the Substack book is interesting because it contains all of these videos whenever they were kind of informing a chapter. But like, I just want to kind of double click on three things here. And again, I want to ask you more for this than I should be speaking. But if you're interested, basically, like the entirety of the book talks about why is cooperation so important? Like, what is the history of cooperation? How did we develop many of the institutions that we currently cooperate with? Like, you know, from like the actual market institutions to like smaller things, like, you know, the way that we interact with each other right now. And what would it look like to improve that with crypto? And so I want to double click on three things. How can we use cryptography to cooperate better? How can we use cryptography to create defenses against the technological risks that we encounter? And how can we use cryptography to cooperate with AIs? And so this one, we basically review a few like really interesting, in our mind, new kind of like pop-ups that are currently being developed in crypto. Like here's a bit on prediction markets, where we had the first one at one of our member gatherings in like when was it, 1999, people voted by sending checks to our offices. So we were like an illegal gambling house, one could say. But, you know, we have like, you can have replication markets now, you know, you could already have them in a decentralized way. Like, and here you have like Gnosis and Augur, like, and a few others, really just discussing what long-term prediction markets could do. Obviously making money immutable. We are like all have tasted our bits of DeFi. What would it look like to create new property rights on the blockchain and to actually create property rights not only for externalities, but also for things like space resources, for space, right? We need better property rights there. And so we had a few on those. How can we use NFTs to actually like engineer new property rights? And then there's a really long one on complex contracts. And so we go from all the way from like split contracts. So basically, what are contracts like where you have a human in the loop? So part of it is automated, part of it can be arbitrated by humans. And then review more like kind of like out there things like dominant assurance contracts, which is a concept developed by Tabarok. We had, I think, Tyler present on VitaDAO here 2 years ago. I think that was when they were incepting. But like basically, we review a bunch of like the different technologies and where they could go. Have a section on DeSci in there as well. But I want to ask you again now, because there's a bounty at the end of this, which has already been claimed, unfortunately. But we'll just pretend it hasn't. I really want to know from you guys, what is the #1 technology that you think is undervalued right now that could really help humans cooperate better? This can be, you know, quadratic funding. It can be something else. Like, is there one thing? It can be from DeSci. It can be a little bit further than DeSci. Really, it's up to you guys. What's the #1 crypto thing where you're like, this is really going to change the world of how we cooperate? Something that,
Does it have to be crypto?
No, it doesn't have to be. If there's another one, go for it. How can we cooperate better?
Mental health technology.
Mental health technology. Yes, we are in dire need of this.
Uniform standards.
Uniform standards. Say a bit more.
Like basically like JSON or schema.org, but like that worked much better.
Oh God, yeah. And having people use that. Not just having it, but also having people use it. Yeah, Jordan.
I was just gonna say empathy, but how about that one?
Empathy is a great technology.
I don't know if you can. I don't know if you can make an NFT of it, but
the empathy NFT. At
Yeah,
least it
definitely.
rhymes. Yeah.
Zero knowledge proofs.
Great one. We have a lot on zero knowledge proofs here. We had Zuko and Howard, who from Aleo, who maybe a few of you know, but like they basically came and like we had a long-term discussion, like what could the future of zero knowledge enabled corporation look like for humans. Okay.
In general, just I think situations where you're not replicating raw data and instead just letting the calculations happen and preserving privacy, that's good stuff.
So we have here, like we list a few that we think are really interesting, like homomorphic computing, secure multi-party computation, zero knowledge proofs, and so forth. So I welcome you if you're like, you know, interested in like a few others, maybe that are not inside of your immediate realm, to check those out. But in the interest of time, I do want to get to the AI one. So let's do the one on the risks very quickly. So one thing that we've done through the tech trees is map out what are all the amazing things we can have with technologies, but they're not just amazing, but they're also like pretty terrifying. So, you know, by democratizing technologies more, and that's definitely what DeSci is doing, right? It's democratizing science and technology. We're also democratizing the risks. And so we now have like less and less people that could create a larger and larger risk. And so with biotech, we have that, like, especially if you have things like, you know, really computing in the cloud, where you don't really exactly know what kind of like, yeah, basically like what molecules you're like mixing in with each other, and you can have dark markets for that and so forth. You can develop like, you know, weapons of mass destruction maybe easily on something like OpenBazaar, but for science, right? Like that's kind of like what we're looking at with DeSci also on the risk end. And we don't really have a way to stop it because it could all be automated, immutable, and it could be private. So that's really scary. And then on the other hand, usually when we talk about technology risk, the solution is like, oh, we need government regulation. We need a strong, you know, state actor that can like monitor everyone and that can do a strong enforcement if it must to against bad actors. And so in this chapter, we also talk about the risks that come from that, because that's also really risky, right? If we have one actor that can really pervasively surveil and enforce, maybe through robots, we're also not in a utopia. And so we talk about what would it look like to use crypto to do that? How can we decentralize defense? And so there are a few really awesome ways on how you can already do private surveillance. So without really revealing much of the relevant attributes, you can surveil in a pretty kind of like interesting, but nevertheless decentralized and privacy preserving way. And so we talk about a few concepts here. And we also talk about like a few other technologies. For example, proof of location is amazing because with proof of location, you can prove that something is in a like that something was produced in a different jurisdiction. And so you can actually actively incentivize people to be decentralized while they're building technologies. And so we go through a few of them. But if I wanted to ask you guys, is there one crypto technology where you're like, this is great, this is going to be massively important for defending civilizations against some of the technological risks that we are producing? It's a more difficult one than the first question for sure. But if you think about cryptography as a defense technology, right? What would it look like to use that to defend civilization? Any bits that you have where you're like, this is really one? I mean, zero knowledge technologies are a pretty good one for privacy preserving monitoring, but like there may be others.
Quantum proof encryption.
Nice one. Yeah, we need to get around to do that anyways. Yeah, that's a good one.
I'm a one-trick pony, but the one I gave earlier was if you are a reporter in a war zone that is afraid for your life, if you were going and reporting on a government that may attack you for your reporting, that maybe you could go and anonymously report things using cryptography.
Great. We actually have that in the other chapter, and that's called a anonymous dominant assurance contract, by which basically you can collect whistleblowing signatures anonymously behind a veil and only unveil them if enough signatories have been collected that warrant a specific claim, so they can all come out together. Okay, cool. So just to let you know, like, please think about this more. We don't only need need to be working on the science and technology, but we also really need to be working on the defense technologies, because if we don't build them, we will have centralized defense technologies and they come with their own risks. Like if we don't figure out how we can make DeSci a bit more bulletproof against the risks, then eventually we have governments coming in and basically like shut things down. And then the final one, the big one, where I really want people in crypto to think about much more is AI. Like, I already said this, there's this often, I think, and this is definitely like not really an accurate description, but like this notion like flying around in someone's head that AI is a little bit more of a centralized technologies, right? And that comes with a bunch of network effects and so forth. And we talk about basically different ways in how we can potentially decentralize AI and why decentralization of AI is important. Because if you have one big actor that you have to align, like if you have one big super intelligence that you have to align with human values, you really have to get the values right. And then you have to be able to incorporate them into a super intelligence that is silicon based, that doesn't share any of your substrate, human context, what have you. And so we come up with a little bit more of a decentralized framework. And so a big one here for us is private machine learning. If we can have more private machine learning, we can maybe create more kind of competitively advantageous AIs to solve specific problems. And there's a bunch of really like interesting pieces already at least written on this. And then you can have blockchains, to really hold systems more accountable. And you can have a few other technologies too, like incomplete contracts and so forth. And you can play around with this a little bit more. But like, I want to know from you guys again, are you aware of any kind of technologies that are right now being developed in the crypto space where, there is a potential for potentially keeping AI safe, secure, accountable? Are you aware of any projects that rekindle already the space between AI and crypto that you think are exciting? It's so early in that space still. I do think in the next 5 years, in 5 years, we'll be standing here and everyone will just be talking about like crypto and AI. I think at least, because there's so much potential. Like, everyone is playing around with their own AI, with their own AI algorithms right now. And, if we could have that integrate with many of the cryptography technologies that many of you are building on, I think we can get to a few really wonderful applications. Private machine learning is tremendous for healthcare, right? That's awesome for finance, like if you want to use machine learning on financial data, you need to have it encrypted. Anyway, so that's really just to kind of bring you a little bit food for thought of, if you think a bit beyond DeSci and take that concept seriously of kind of using this decentralized concept to collaborate better across humans, to defend humans, and to collaborate with AIs, what would that look like? Because ultimately, I think it's you guys that are building these technologies. And if we don't come up with this, like, we're going to have, I think, futures that are like less wonderful and that are less decentralized, that are less collaborative in this way. And so I really just want to, appeal to you to kind of think further. I think DeSci is already outrageously ambitious, and I love it. But I think beyond that, on the long run, we can really take that and take that concept and apply to every single field that we're working in, right? Including ultimately how we collaborate with AIs. And so if you're interested in exploring any of this further, then you are welcome to, send me a Twitter DM. We have a bunch of events. For example, Vision Weekend is the one that's coming up. It's in a castle in France. It's our annual member gathering where we basically bring the best people from all of our different technology tracks together in a castle in France and at the Internet Archive here in San Francisco. And we just do a review across different technologies, just like what the hell happened this year? How can we shape these technologies towards like positive futures? And so we have like multiple tracks in parallel on brain-computer interfaces, crypto, AI, energy space, new funding resources. We have a big DeSci track in that as well. And there's still a few tickets, but the one in France is already coming up in 2 weeks. And so if you want to join us, please, there's still a few tickets left. There's also an application form for subsidized tickets. Otherwise, I would say if you're interested in just getting your kind of fingers wet or like hands wet in these technology areas, feel free to apply to one. So we have these like monthly seminars in each of these areas, and then application form basically just lets you in. You get a screening, like an interview, and then you're in that group. Like it's a bit like a seminar group, really. And we have these workshops that I, just showed you the crypto workshop of. So if you're interested in collaborating more, then please go for it. We also have the fellowship that I mentioned. But yeah, if you're interested, please talk to me. You can tweet at me. I have the physical book here in case you're interested in that. And finally, I should say we're also hiring. So we're always looking for people that are self-driven, highly motivated, and can kind of carve out their own field of area of work. And so frankly, whatever you're working on, if it's Foresight aligned, please reach out to me. We have a job description, an open position here, but also you can just tweet at me. So we're always looking for more collaborators and as we're growing relatively fast. Okay, thanks everyone.
Wow, that was amazing. Thanks so much, Allison.
I'm very, very honored to be here with you. Thank you for the invitation. Today, we're going to talk a little bit about what we've been doing in Genobank. We started in 2018, and this is a little bit of my story. This is because in 2017, my son was diagnosed with a rare disease, and I was already involved with the CryptoKitties as a user. So I got inspired because my son was diagnosed with Glanzmann thrombosthenia. It's affecting 2 of his genes. So we have a lot of hope in gene therapy because while it's known, and there are more than 10,000 now rare diseases, as you may know, there's no cure. So this is also a number that is known in the rare diseases space, because 7% of human population has a pathological mutation, and that is Mendelian, right? So if you have the mutation, you will have, or you will express the disease or the pathology. And these are also called orphan diseases, as you may know, because 94% of them do not have a treatment. And this is how DeSci can help, right? These are the main concerns that people have not to participate on clinical trials, right? Is basically 4 questions that in essence are lack of trust, right? Because we cannot blame the society or the participants, we have a lot of stories. The last decade is full of them, that Web2 companies have either sold our data or simply been hacked and they leaked our data. This is the most recent one, is Ancestry DNA, sold to Blackstone, BlackRock, I believe, in $4.7 billion. Because our DNA data basically is their competitive advantage, right? So that's the main reason they silo it. So this is the main problem we are working. This is the inspiration for Genobank to solve lack of trust, because this means no biosamples for researchers, right? Which is the main, let's say, declared limiter, right? Shortage in biosamples. This is the opportunity. The opportunity is huge. As parents, as individuals, we majorly we do agree on donating or sharing our biosamples and biodata for research, but we have to give a detailed control and consent mechanism. So in 2018, I wrote 3 patents. One is the individual DNA wallet, the other is a family vault, and the third one is a vending machine for Web3 DNA saliva kits, right? So it's a vending machine that will only use your wallet to register any biosample extraction kit, and you will be able to send it to any laboratory. So it's like kind of a universal testing kit idea. They're still pending. But in the meantime, I wrote a paper with Dr. Giselle Waters that is called Privacy Laws, Genomic Data, and Non-Fungible Tokens, and is very, very based on the GDPR's Article 7. We were fortunate. We will not only be published. It's a peer-reviewed publication. It's the Journal of the British Blockchain Association, but we also were awarded as the best blockchain application in life sciences, and this was 2020. Then in 2021, this paper was selected as one of the 22 references in UK's national roadmap, blockchain roadmap toward 2030. So we are one of the reference there, or the paper, and we are very, very honored about that. And because we were I think the first company or the first project to propose the idea to use NFTs to represent digital rights, right? So with this paper, I don't know if you have heard about William. William is the lead author of the ERC 721. He's a marvelous person. He's my friend, and he helped me to co-author the BioNFT, as we call it. BioNFTs was the first, and still the first, biosample consent NFT based on the ERC 721. And the main difference is that ownership is always locked, right? You will always own your biosamples, but you have permittees, right? It's a permission-based system. It's still working, and basically is just a variant of the ERC 721. This is the basic functionality about it, right? So once you tokenize the biosample, there's 3 claims, minimum 3 claims on this token. Is the identity in the blockchain of the laboratory that issues the kit or that is going to process your sample. It's going to be the identity of the custodian of your biosample. The second claim is the serial number of the tube or the kit. And the third claim is your identity, your anonymous wallet that will issue, the system will issue an NFT, and the consent NFT will be issued for the laboratory, right? I remember the GDPR is very based on consent, and this is a way to verify cryptographically which samples and which data sets are still active, right? Are not revoked. So we launched in 2020 the first kit with Somos Ancestría. Is an ancestry company based in California to serve the Mexican community. Basically, they have an interesting ancestry reporting map that will tell you if you have a pre-Hispanic ancestry, basically. Remember, in California, 1 out of 2 of the residents, we have a Mexican origin. I am Mexican myself, and this is a very dear project for me. So this is the kit has a QR code, and it registers, and the person will just send the kit without revealing their identity, and they will just receive the report, right? So then the pandemic came, and we launched what we call the lab NFTs. Lab NFTs are basically revocable credentials for laboratories that will allow them to issue certificates. So the governor of the state of Quintana Roo in Mexico City, where Cancun and Riviera Maya is, they call Genobank, say, hey, help us to tackle the big problem that we have with fake certificates, because even taxis were selling fake certificates for $40 to tourists, right? Let's remember, Cancun and Riviera Maya receives more than 6 million people as tourists. So we connected with 30 laboratories, and so far we've been protected. We have helped protect 324,000 biosamples. Now we have extended this functionality to 25 tests because we incorporated the HL7 protocol that comes directly from the machines that perform all these tests, right? We also launched last year the first paternity test that is verifiable on the Avalanche blockchain. We have more than 100 tests so far, and it's based on 25 DNA biomarkers. And if the resolution allows, if you like to scan this QR code, this is how maybe an authority or a judge, because these tests have a lot of legal implications and they are very, very prone to Photoshop. So this is the way you can verify the original copy, right? It has a lot of claims on it. That's why it's very, very populated. But it works for its purpose, because it's proof of provenance and proof of authenticity, right? Proof of authority. So this year we continue with Somos, and now we launched the first ancestry report using BioNFTs in the modality of compute over data in a Dockerized way. So in this way, once you have your data with Somos, you can run the algorithm without sharing the data with Somos, right? So if you only want to purchase their bioinformatic pipeline, we can do that now. It is not running on IPFS right now or any decentralized storage. We're working on it. It works on AWS. But the main thing is that this is like a vending machine for bioinformatic interpretations without sharing the data with the company, right? So it's still a lot of UX and UI. Is the one, the report is one in the right. Still not very pretty, but now it works and it saves the consumer they don't have to share the data with the company anymore. So this is what we're working next is using the ERC 4907 to enable people to rent their data. As you may know, the ERC 4907 is to receive like you can rent, because for us DNA is like the real state of biology, right? It doesn't change and it's unique. So I believe it's a suitable model. And then you'll be able to control the signed or the authorized copies again with BioNFTs. This is almost the end of the presentation. We also offer Metaverse for DNA researchers as a service. So this is very simple and very, modest. But the idea is that they will have, hopefully, I mean, this is on Cypher.io, but this could be the room of a researcher, like talking to their donors and explaining to them what's the new paper that came thanks to their biosamples and biodata. Or this could be your family room full of your family or individual set of biosamples, and you can call researchers to help you out to say, hey, I have a rare genetic disease, please come here, explore the data. You just need my consent, request the consent. And this is a new space, a new, obviously, collaboration space for research, right? And obviously the participants, again, are just avatar based and their privacy is there. So so we have more, again, like 30 laboratories are using our protocol. We have 3 white label kits. Hopefully next year we'll go to 10 at least. And we charge a little bit less than $1 for all the NFTs. So it's very affordable because we work in Avalanche. I will leave you with 2 more slides because there's many trends that will say that 100 million humans will be sequenced in the next 7 years, 7 to 8 years. So today it's not even 1 million. I'm talking about whole genome sequence. So it's the opportunity is huge. Now, Illumina has announced 200 cost per genome for 2023. And there are 5 national initiatives for newborn sequencing, right? Based on governments, Canada, United States, UK, Australia. So newborn sequencing is coming. So what we really need, and it was in the previous presentation, is property rights for genomic data, right? Is digital rights, or we need to encode privacy using NFTs, or at least this is what still be our thesis. And we will focus a lot, if somebody's interested, on getting to 1,000 privacy preserving family genovaults, as we call them, that are controlled by mom and father and mother, or mother, depending on how is the configuration of the family. And we have called this project Baby Sick NFTs. And basically, we want to give agency to parents about the genomes of their babies, right? So thank you very much. This is everything I have for you. I think we share this vision that the future, in order to democratize access for genomics, is decentralized. Obviously, I'm Mexican, so I'm very interested in diversity driven. So we have to encode that and try to incentivize diversity. Many talks I give, like, hey, let's look at the patient as a data partner, not as a data target. Certified data for AI is always needed, affordable, not speculative, because we've been very, very cautious of not launching an ERC20. Even we saw all the ICOs coming and going. We still don't need a token for the moment. There are plans, but we think, I believe, to grow the network first. And finally, the main objective of Genobank is to help save lives. If we know more about our genomics, we will be having more clinical genomics, and then better outcomes. Thank you very much. I really appreciate the opportunity to be here. There's my calendar. If you want to talk, I'll be more than happy to to talk.
Incredible. Let's get a round of applause for Daniel.
Thank you.
We got to get you in for a full talk next time. That was super interesting. Thanks so much for that, Daniel.
No, thank you, Omar. I appreciate it.
Hi, everyone. Michael Fischer. Good to see you again. This time I'm going to be talking about DBDAO. So this is the project I sort of work on full time. And we have a team behind it. And it's basically like the Firebase for Web3 DeSci or apps. And I'll explain how we're going to do it. So DeSci and DData. So we've talked a lot about funding. We've talked a lot about sort of building DAOs. But now we're going to sort of, the thing that I'm really interested in is how do you build, how do you do the science? How do you do the data science? How do you do the collection of data? How do you curate these data sets? How do you build these sort of data pipelines? And so, scientific research is based on empirical data, and DeSci has the ability to have many eyes on individual pieces of data and hopefully lead to more reproducibility. So we looked at sort of the landscape in doing traditional web app development or any development. And for Web 2, you have, if you want to do storage, you use S3. And for Web 3, you do IPFS. For hosting, you can use Vercel. And for Web 3, you have Fleek. For name service, you can do DNS. For Web 3, you do ENS. Servers, you can do AWS Lambda. For Web 3, you can do ENS, you can do smart contracts. But like the database component is still sort of this amorphous missing part of building like a Web 3 style application. So why do we need it is like the goal here would be to have one is to incentivize people to contribute data. The fact that people are putting data into databases today and not being paid is a little bit backward. Like the fact you don't ever want to pay for data storage. You should be paid to have your data. You should put your data in somewhere and get data out. Money should come out the other way. So that's like negatively priced data. The other thing is like data should live online forever. There should be for all this scientific research, you need data permanence, and for either whether you're building an application or doing science, you should have composability between data projects. So when you have a database, you should be able to link that to another database and have it interoperable. And you can't really do that today with traditional databases where they're closed and on a centralized server. Data ownership, so being able to own the data that's created. Privacy, if you need it, but through encryption, the data should be tied strongly to your identity. And you just want the database to be generally interoperable with Web3 standards like your wallet, your ENS, sign in with Ethereum, lit protocol, and all these different things need some sort of native data and just sort of like be very interoperable with the existing data sets. So we looked at sort of like what the database landscape looks like as one of the things you want to do is incentivize good content and disincentivize bad content, which we'll talk about in a second. You want to pay people to administer the database so that they're curating content in real time. You want to be able to audit the database. So right now you submit data, you don't actually have any verification that what you submitted was actually put into the database. That row could just disappear. So you need to be able to track the changes that are being done to a database. You want to be able to link databases together, and for a lot of applications, you want it to be default open so that you have so that you have people can see the data. I think there's just many applications where openness seems to be better than closed, and you want it to be indexable and an easy drop-in SQL developer experience. So I'll just say like right now we're doing projects with LabDAO and SciDAO to do large-scale like psychedelic research on like a general clinical trial. And then we're also working with CharmVerse. And so I'll just, this is like a one slide overview of what DBDAO does. Is basically it like incentivizes, it provides like the structure to incentivize people to contribute data into a database. So a database can monetize in a variety of ways through like subscriptions or through advertisements or through a benefactor paying for scientific research. And anyone who contributes to that database and contributes data, whether it be a personal health record or a lab experiment or anything, we want to be able to pay those people. And then what we do is we like tokenize every piece of content. So every row in the database becomes an NFT that can be bought or sold. And then like sort of like what they were talking about in the last lecture. And then the database is then managed by a DAO. So an important part is when you have an open database that's sort of accessible to everyone, the curation process of creating the data set is important. You don't just want a lot of people entering spam. So the idea is like when people enter data into the database, then we share the rewards equally. And like the top case like business model here is that individually, when someone has one piece of data, it's not super useful. But when you start to compile larger sets of data, you have like non-zero sum value created by multiple pieces of data. So there's many different, we offer people tools basically to curate a database based on different standards. You can look at like, some people want to have very easy to get into databases if you're just playing around with data sets. But if you're about to publish something on a clinical trial or you're trying to publish a paper, your standards for which you allow data into or out of your database are going to vary greatly. So every row in the database, when you add a row to the database, what's actually happening on the back end is you're minting an 1155 token, and that allows for a lot of interoperability. This token, like a token, traditionally an NFT is like backed by a Bored Ape or something, and the IP of that picture. In this case, it's backed by the JSON that is in there. So if you have a piece of data, we encode that into a JSON object and then wrap that in an NFT. And what's cool is once it's in token form in an NFT, it's compatible with all DeFi protocols. So you could do lending or staking based on the IP of your NFT, which is kind of cool. So then lastly, another thing is like, we have this concept of like incentivizing good content and disincentivizing bad content. So the incentive to like get into the database is you get paid when your data is used or successful. So that's sort of the carrot we use to incentivize people, but you also want to disincentivize bad content. So we have this concept of staking on rows. And basically when you submit a row to the database, you have to submit it along with like $1. Say this is a parameter set by the database administrator, and or 50 cents. And then if your row is accepted, you get your 50 cents back by the database administrator. But if your row is rejected, and if you're just submitting spam to the database, you get slashed and you don't get your deposit back. And the idea here is this sort of disincentivizes people from posting bad content. Now, the question is okay, then you sort of have to trust the curator. Like what prevents them from just slashing everything? And we basically have a log, because everything is on the blockchain, of every decision that they've made. So we have this like a log chain, and you can go back and you can look back to see if the curator has been making decisions of removing content or not allowing certain types of content into the database, then you should not trust that curator anymore, and you should move to another database where the curator is doing a better job of curating the data set. So we have this idea that like we want interoperability. So we work together with schema.org in order to have like open standards for things. So if you're curating cell data or book data or person data, we encourage you to use things that are already schemas that are already available on schema.org. And we have a builder to help you build your database and schema for your database in a very open way. So then it comes to the idea of like a database administrator, and the database administrator here is actually a Gnosis safe. So you could have many people. So the idea is if you're just one person and you're curating a large data set, you don't want to have to make every decision yourself. So what you can do is you can deputize a number of people to also work on your behalf to accept or reject content. And they're all multi-signers of this Gnosis safe. And so a Gnosis safe can be one person. It can be a team of people. It could be a jury. It could be a DAO. It could be people on Mechanical Turk. It could literally be anything. It can be an AI too, which is interesting. So you can have an AI like GPT-3 automatically accepting or rejecting things. So if someone were to build a social media application, or if you wanted to have a large scale science project, you could train an AI to be a signer on the Gnosis safe and automatically accept or reject certain types of content. We also do use encryption to encrypt. Sometimes you want certain columns to be private. So we use lit protocol, which is basically like an NFT-based encryption mechanism to encrypt certain parts of the database so that only certain people have it, which is kind of cool. Is like, here's a use case, is like have all the names on one side and then the email addresses over here. To get access to the email addresses, you need to have the NFT that decrypts things. So that's kind of interesting. That's be useful for DeSci. And then we can do ZK queries on certain things. So we're working on this thing to basically to have a Merkle cache basically of the database, and then do ZK queries on certain parts of it. And here's a short demo of how it works. So this right here is the database. So we mint a database. We have different parameters here. Here's the schema for it that defines the database. This is for the SciDAO integration. Here's the schema we use. These are the defaults that exist. And so what we do, we're on Arbitrum and Avalanche right now. So we mint the database and MetaMask pops up. The database was minted. We go see the transaction on Arbitrum. So that's the transaction that mints the database. Then what we want to do is we want to add a row to the database. So these are some defaults that are already there. And then we mint that database, we mint that row. Then the row gets along with that slight deposit that we had, which is like, in this case, $1. And because we're the admin, we can have the ability to add or remove this row from the database. So for fun, we'll remove it. So that's kind of the demo of how it works. So the rewards. So when you add, the database can monetize. A drug company buys pays a lot of money for all the data that is in the database. The network gets 10%. The database administrator, the person who organized all the data, gets 30%. The scouts get 60%, and then the viewer, the person who views the data, we're playing around with this idea of having 5% go back to them. That's it. So you can check out dbdao.xyz. We have a white label app, open source, freely available. The whole project is open source. You can email me or telegram me on Michael, and my email address is there. Thanks.
So my name's Elijah. Met a few of you today. It's been awesome learning about all of your projects. So thank you for sticking around to hear about mine. This InReal Lab is a new project that I've been working on. So my background is as a molecular genomicist, trained as a molecular cellular developmental biologist. And after grad school, so I'll give you a little bit of introduction of how I ended up with InReal Lab. After grad school, I started a cannabis genomics lab in my garage. Did that for about 6 years doing diagnostic testing, developed an ancestry test for cannabis. And instead of going the route of Ancestry, 23andMe that many of you saw earlier, always decided to take the position that we were consultants. We didn't own the customer data, just baked it into our TNCs. The customers own their data. And this led to me forming a DAO, and it was DAO governed data marketplace. That whole thing kind of went up in smoke. Still working on the DAO, but it turns out it's really hard to run a diagnostic lab, especially when you're a research scientist for 6 years. So we ended up shutting that down, but I still have the actual lab. So down in Santa Barbara, we have InReal Lab, and that is where this presentation has come from. And I'll tell you about a little experiment that I'm doing now. So InReal Lab, the goal is to empower citizen scientists. So I taught a lot during grad school, TA'd all 7 years. I went back as an instructor afterwards. And I firmly believe that anybody can learn anything they set their mind to. And that if you're given the opportunity and someone that believes in them, right? So that's kind of my perspective and my philosophy for turning my diagnostic lab into a educational program. So what we're going to be doing with InReal Lab is focusing on citizen scientists, people with DeSci projects that need access to lab space and renting it out as a co-working space, and then empowering the people that are renting out the space to then develop their own courses. And we're going to do it with verifiable credentials so that they can demonstrate they have a very particular set of skills. I asked if you're having fun, I meant it. So our educational curriculum is going to cover, it's going to start with some virtual courses, right? Be accessible to anybody, sort of like the Coursera model where you can access all the content for free, but then there's going to be a fee to get the verifiable credential. And that's going to be sort of the revenue model for that. But we do have a physical lab and did produce a bunch of DNA collection kits and materials and things like that for testing. So we're going to be doing hybrid courses where people that enroll in the course will be shipped a kit where they can do DNA extractions, they can learn plating, and they can even send samples back to the lab to have them run in aggregate and then come back for a future course and analyze the data. So the first course we're going to be doing for a hybrid course is kombucha metagenomics. So anybody who enrolls in the course will be growing kombucha using the local spores in the air, just sort of not seeding it with kombucha from the store or something like that. So hopefully we'll have samples from around the world that we can then pool when they send them back to the lab. We'll analyze them, get the metagenome sequenced, and then they can come back for a future course, analyze the data, and even be included as authors on the paper. And furthermore, once they get some sort of verifiable credentials, or a few the early people in the lab are going to be people I know, they can come into the lab themselves and actually host IRL in real life boot camps. So the whole idea of this actually started with people in Cannabis Genome DAO asking me to teach boot camps to get people ready for the cannabis industry, or to learn more about how this testing is being done. So there was actually just already demand for this sort of thing, people asking for these kind of classes, and I was like, all right, that seems like a good idea. So if you know anybody that's interested in learning about this, that needs access to lab space, really just trying to be as flexible as possible and support projects. So the lab itself is fully equipped, molecular genomics lab, providing support in terms of reagents on stock, in stock, and just like experimental design support. And hopefully it'll be a good collaborative environment. And the real goal is there to train people who are interested in things that may not have either access to traditional institutions, either financially or in a different country, and get them ready to join the job force, and then hopefully get job placements and get citizen scientists working in scientists. So part of this is just creating content. So I've also launched a podcast called DeSci Party. So if you're interested in checking that out, I'll be hosting an interview with Jocelyn Pearl tomorrow morning. And yeah, just trying to get more educational content out about science, DeSci, citizen science. So a little bit about the actual co-working space itself. That's me in the lab. So for any of you that don't work in a lab, I just wanted to include some fun visuals. And yes, we play music in the lab. I asked if you were having fun. Oh, I can't advance the slides. You're stuck. Thank you.
That's it. Go to the next slide. No. Oh. Yeah, let's see if it works.
There we go. Cool. So the whole idea is also to really empower these people that are going to be coming into the lab to be their own PI, right? Most people think to start a lab costs millions of dollars. I think that, we know, many of us know that it's really hard to come by science funding. I think it's possible to fund your own science. I mean, many of us learned this in grad school, right? You can TA your way through grad school. I think that should be continued to be possible and more accessible to more people. So that's what I'm trying to provide with IRL, with these boot camps. The instructors of the boot camps will get to keep the majority of the profit. They get to run their boot camps, essentially be their own PI, have the access to this lab space to run their experiments when they're not teaching. And access to this network. So the ability to recruit students easily for their courses and just kind of be able to focus more on their research and basically fund themselves through teaching. So there's a couple of examples to compare this to, and these images are just fun images that I took of. These are actually a central nervous system of Siona intestinalis that I took pictures of under fluorescent microscope. So because we're down in Santa Barbara, right by the water, so we can work on fun invertebrates. So there's a couple other examples to compare to of, sort of instructor profit sharing systems, right? We're all familiar with like Udemy, Skillshare, Coursera, I mentioned earlier. Most of these, leave very small amounts of profit to the instructor. Our goal with IRL is to do basically about 80-20. Again, this is being developed in practice, so I think that's pretty good revenue share. So just kind of trying to make it as familiar to the current paradigms of Web3 as possible, using a Discord, using a Notion, hopefully using a CharmVerse, shout out. So that's a wonderful software to basically issue these bounties where students can submit assignments, instructors can submit their lesson plans. We'll be using LearnCard for verifiable credentials, and we have a physical laboratory, and working on token and governor contracts. So I won't say too much about verifiable credentials because we already discussed those plenty today. But for the token and governor contracts, so I'm a DAO degen turned regen. I love DAOs. I started working full-time in DAOs over the past year. My hypothesis here for this experiment in decentralized education is to decentralize governance over the physical and digital infrastructure for not just the education, but the research as well. So part of the philosophy for Cannabis Genome DAO was not your lab, not your data, right? When you're sending your DNA to a lab, they do have it still on their server. They are still generating that data. There is that point in there of vulnerability. What if the people that are sending their DNA can come do the experiment themselves? They have governance and ownership over that infrastructure themselves. So that's kind of where I think things are going to end up going with this, and we'll see. So stay tuned for IRL 2. And we are recruiting instructors now. So that's it. Thank you. Oh, and there's 2 other confirmed instructors that are developing courses already besides myself, and 1 other on the fence. So got a good little cohort of instructors getting started, and hopefully you'll be seeing courses from us starting in January, and having people in the lab as well and starting in January.
Elijah, that was incredible. And quick shout out, have you slept in the past day or so?
I finished this presentation at 7 a.m. after getting off the bus.
Well, thank you very, very much. Just for a second, does anybody have any questions for Elijah or for Michael? Or I don't know if Daniel is still on the call right now. Please.
Do you own the space? What exactly is the real estate deal? And how big is it?
What is the real what?
The real estate, the lab space.
Oh, the lab space. Right now it's only about 500 square feet. We are the tenant who is next door. He's got a pretty nice laboratory setup as well, and he's going to be retiring within the next few months. So hopefully we'll be expanding it to about 1,000 square feet. And partnering with UCSB. So we're about a mile away from UCSB, which is where I went to grad school. So still have very tight connections from there. When I was running the diagnostic lab, we had a staff of over 25, they were all students. So there's a huge flow of people, from the local community as well. Yeah.
Beautiful. Any other questions for Elijah, Michael, or Daniel? Let's go find out. That's quick. Daniel, you still on the line? I think he is. Can you hear us okay?
Yes. Hello, Omar. Right here.
Hi,
Very
hi,
interesting.
Dan. I liked your presentation a lot. It looks like you did a great job. One of the question I had was you showed a slide basically where people are able to put their complete medical record in an NFT or their DNA in an NFT. That to researchers, they maintain the argument that you made, I believe, is that people whom the DNA was taken, the NFT still belongs to them. I'm confused about that because when I've seen DNA processing, you need to go on and you have like a terabyte of data. It winds up going through lots of algorithms. At the point that the researcher gets hold of that, whether it's surrounded by an NFT or not, he has access to all the bits. How is it that the patient retains control while that data is being worked by the researcher? That's confusing to me.
No, that's a very good question. So the first objective that we have is to eliminate all the cases where the bioinformatic analysis is very basic. For instance, an ancestry report, right? The ancestry report bioinformatics are one of the most simplest. And I don't want to be disrespectful to the people who are bioinformatics in terms of ancestry, but it's not that big of calculations, right? So you can avoid or you can protect people from the need to share their data in order to obtain an ancestry report. So there are, let's say, levels of complex to simple bioinformatics. Now, that being said, if somebody wants your whole genome, today you have to share your data. There's no way we can, with the computing power that we have, to implement zero knowledge proofs or homomorphic encryption for a whole genome clinical grade, which is usually 130x resolution, which is like the number of times your genome is processed by the machine, and it weighs as you were saying, like 200 gigabytes, right? So that's a clinical grade whole genome. And today, we can obviously open the debate in a good sense, but it would be super, super expensive to implement homomorphic encryption for these very large data sets. So the good news is that, to be honest, genomics right now is studied in regions. Like, for instance, I can tell you about my son. So the mutation of interest in my son is in the chromosome 17, and specifically in 2 genes. Let's remember that we have approximately 22,000 genes. So you would only be able to share that region and create the corresponding NFT privacy rights or property rights or distribution rights. We can name it in a many ways.
But even in that case, what's to prevent outright theft? That is, you go on and give a section to the guy, he's got his algorithm, it goes on and does the matching or whatever it is. Is it homomorphic encryption? Does he just get it? Do you trust him? Do you run that? You can also run the algorithm on your side, it turns out, with the data, because the patient trusts you. There's several mechanisms to deal with it. How do you deal with it currently?
Currently, it's a trust mechanism.
Okay, thank you very much.
Yeah.
I had a question for Elijah. I'm sorry, sorry for the asynchrony here, but you mentioned that there's like an 80-20 profit split between each of the courses. Do you have like an IP split for anyone who generates anything in your lab or anything like that?
That is a great question. No, not yet, but I would love to discuss that. As mentioned, the whole goal right now is to decentralize the entire thing.
Yeah.
Top to bottom. So any IP generated would be part of that.
Yeah, because I think a lot of people stay in academia for their lab access, right? Like a lot of postdocs, a lot of PhD students extend their academia careers for that access to a lab. And if there were private labs to go, share their skills, explore a hypothesis in a IP friendly environment, they would probably jump at that.
Yeah, no tech transfer office here. So yeah, I went through that big time when I was, finishing up grad school. Even though I started a lab in my garage, I still had to get the tech that I developed at home transferred out of the university because I was a grad student. Yeah, and that would be, if they're coming in and they're working, they're going to earn tokens for teaching, for doing things, so they already have ownership of that system. And then if they produce IP, I would guess that would be part of that as well. They'd, get initial incentive to do that. And then, if it was successful, ongoing.
Yeah, I know a lot of people in academia who have ideas, but they're kind of afraid to pursue them under their current IP structure or anything like that. So it'd be interesting,
welcome to come.
Definitely incentive.
Yeah.
I also had a question for the second presenter with the database. And that is, so same question, sort of. I've got a terabyte of data that sits inside the NFT. Where does it sit? I mean, is this a service that sits online and I can upload a terabyte going back and forth to your system? Or is it software that I keep, since it's open source, do I run it on my servers, or how is that?
Yeah, it's on IPFS, and then you can encrypt certain parts of it to restrict access to it.
Okay, thank you.
Great questions from everybody. Oh, excuse me.
Hi, I have a question for Elijah. How would it work if people wanted to validate things in animals and stuff? Like, did you say you were partnering with another university that has an animal facility, or how would it work?
Great question. Yeah, so we're not currently, sort of BSL certified or CLIA certified or anything like that. So right now we're limited to doing things that don't require animal protocols, but could potentially, we are right a mile away from UCSB. So there's plenty of labs that, I work with and still in touch with that do have those sort of things. They have IRB and all that stuff at UCSB. So haven't started pursuing that yet, but it's definitely, if somebody came in and they were interested in doing that, it would be totally on board.
Just awesome questions from everybody. Let's get one more round of applause for all the guys who gave speed talks today. That was great. And I have bad news for everybody. This is it for DeSci SF. So
It has been a fantastic day. Let me just go and pull up some really final slides here. Oh, yes, the best. Should I get it back up on screen? We used to have the webcams better aligned, but it's not bad. So it has been a heck of a day today. Let's see if I can get back here to the beginning. I hope you guys, have enjoyed every bit of it. It is still a very early space that we're in over here. Oh, let's see if this one's going to work. I was honored to go and give that introductory talk today. Early feedback is that we were able to highlight how fast this field is growing. That tripling of known projects in the past 10 months is pretty exciting. And you guys even put up with my data nerd tendencies. And if I could encourage one thing today, remember confidential computing. I think it's going to be the safe way to enable a lot of the interesting incentivization models that we've looked at so far. Then we got to see, how Iryna and Baechle are enabling endless computation on 20 petabyte data sets. Talk about limitless over there. This is such an incredible infrastructure for open science, and I'm so excited about what they're doing. And then came my experiment of the day, which was speed networking. So show of hands, how many of you had a good conversation today during the speed networking sessions? All right, that's not bad. And how many of you paid any attention to the colors on your name tags or my nagging? Many fewer, many fewer individuals, but I appreciate the efforts here. Anybody want to give quick feedback or suggestions on that networking stuff? We were really trying to run an experiment there. Next time, we'll iterate. I'll catch up with everybody offline. Well, then we had Jordan wrap up the morning session with a great talk about, sort of the science associated with space and DAOs. I was particularly glomming on to everything related to funding and, thinking through those governance models, which I think are really tough. Then after lunch, we had Natasha's discussion, of her vision for a scientific ontology that was really beautiful. So beautiful, in fact, that, we had great conversations with Artem pursuing a similar space and Allison with Foresight's tech trees. So it's pretty clear to me that, the future will be built on structured interoperable data in a way that's really cool. And, Michael is building part of that infrastructure with DBDAO. So, I was pretty blown away with this concept that every row of data is an NFT and each database is a DAO. Just incredible. Again, I'm a data nerd and I think about this stuff all the time. And, that and the incentive models for data variety and usage were really, really amazing to me. And I think, Alex, is he still here? From CharmVerse, really, I think he may have the best idea on how to actually incentivize communities to come about. Marketing is not my forte, nor community building, but it's essential to Web3. We're going to make it together, if we know how to collaborate effectively. And really, leadership from organizations like Foresight, it really helps. So Allison's talk was a wild demonstration of, how there's pretty much no subject in these domains that smart people aren't thinking of. And, that she can go and connect you to these other thought leaders is such a powerful, incredible thing. Then we got the speed talks, and Daniel chatted with us about BioNFTs and lab NFTs. And what was the other one? We had paternity certificates and ancestry and baby genes, like really, really incredible stuff. And then, Elijah came in embedded cleanup, talking about the spirit of Web3, an expert and, sort of, making himself available for others to educate them on what's happening. And then thinking about how to scale his efforts to help as many others as possible, which is, really, really beautiful mission that I think speaks to DeSci. So let's get a quick round of applause for our speakers today. Great job, everybody. So, I want you all to remember today, because we are at the very early stages of some pretty new stuff. I'm so grateful to Piano Fight for hosting us today, because it felt like the perfect venue for, this community at this moment in time. But, I want to see this community over at the Moscone Center in 10 years, right? And I want to see the companies that we were reviewing on this list over here sort of becoming household names and becoming, the people in science that are remembered for going and pioneering something different. And I think we're all going to work to make that a reality together. And finally, I want to give one more quick shout out to our sponsors. Thank you. Please, another round of applause for everybody that funded our ability to get together today and lunch and everything. Weavechain is going to go and buy the first round of drinks over there before we decentralize the bill. And then last but not least, anybody who is not ready to let the day end, you can come and join us over at Executive Order at 6:30 for another round of drinks. But thanks to everybody, and please enjoy the rest of the day at the bar.